We all have that sci-fi dream. You step onto the deck of a starship, watch as Earth shrinks to a pale blue dot, and set a course for the nearest spiral galaxy. It's a powerful dream of discovery, of seeing alien worlds, and one day returning with stories that would reshape history. But it's just that, a dream. Welcome to the science for deep sleep. If this kind of calm exploration into the universe helps you unwind, consider liking the video and subscribing to the channel. And wherever you are right now, whether near an ocean, a forest, a city, or somewhere quiet in between, feel free to share where you're watching or listening from. Imagine you left today on that grand adventure, heading for the Andromeda galaxy on our fastest ship. By the time you arrived, over 2.5 million years would have passed on Earth. You wouldn't be returning to the world you knew, but to a planet where human civilization is a forgotten memory. This isn't an engineering problem we can solve with a better engine. It's a fundamental limit, written into the fabric of the universe itself. This is the stark reality of intergalactic travel, and today, we're breaking down the hard physics and real numbers that show why a trip to another galaxy is a one-way journey into the void. Picture it. You pack your bags and climb into the fastest vehicle humanity has ever made. A machine that, at its peak, travels at over 430,000 miles per hour, or about 192 kilometers every single second. At that speed, you could fly from New York to Tokyo in under a minute. Your destination is Messier 31, the Andromeda galaxy. The journey sounds epic, but here's where reality delivers a knockout punch. Even on this record-breaking spacecraft, your trip to Andromeda would take approximately 3.9 billion years. Not million, billion. To put that in perspective, our entire solar system is only about 4.6 billion years old. You wouldn't just be late for dinner. You'd arrive long after your homeworld, your sun, and maybe even your entire galaxy had ceased to exist in any recognizable form. Your epic voyage would be a one-way ticket into the deep, cosmic future, with absolutely no possibility of return. The tyranny of distance. Before we can even talk about speed, we have to wrap our heads around scale. Let's be honest, our brains aren't wired to grasp cosmic distances. We think in miles, maybe the 239,000 miles to the moon. Even that feels huge. But that's just the first step on a ladder of unfathomable size. Let's start with something we've actually done. The Voyager 1 spacecraft, launched in 1977, is one of the most distant things we've ever made. Traveling at over 38,000 miles per hour, it's been journeying for nearly half a century and has only just left our solar system. If you pointed Voyager 1 toward the asterisk nearest star system, Proxima Centauri, it would take about 80,000 years to get there. Recorded human history is only about 5,000 years old. So, a trip to our closest stellar neighbor would take 16 times longer than our entire civilization has existed. But we aren't talking about a neighboring star. We're talking about a neighboring galaxy, Andromeda. On a clear night, you can just make out a faint, fuzzy patch of light. That's the Andromeda galaxy, the most distant object your eyes can see without help. The light you're seeing began its journey 2.5 million years ago. So, when you look at Andromeda, you're seeing it as it was when our earliest Homo ancestors first walked the Earth. A light year is the distance light travels in a year, and light is the universe's ultimate speed demon, moving at about 186,282 miles per second. The Andromeda galaxy is 2.5 million of those light years away. The number is so big it's almost meaningless. 2.5 million times 6 trillion miles. Let's try an analogy. If the distance from the Earth to the Sun 93 million miles was the thickness of a single sheet of paper, your stack of paper to reach Andromeda would be over 1,000 miles high. This is the real problem. It's not about building a faster rocket. It's about crossing an ocean of emptiness so vast it challenges the very meaning of distance and time. The universe doesn't care about our ambitions. Its scale is absolute, and in the face of that scale, our greatest achievements are reduced to a crawl. The gap between galaxies isn't just space to be crossed, it's a chasm of time to be endured. Our fastest machine versus the void. So, the distance is absurd. But what if we had an equally absurd machine? Science fiction gives us warp drives, but let's stick to reality. What is the fastest thing humanity has ever built? That title goes to NASA's Parker Solar Probe. Launched in 2018, the Parker Solar Probe is an engineering marvel on a mission to touch the Sun. It uses Venus's gravity to slingshot itself closer and closer to the Sun in a highly elliptical orbit. According to the laws of planetary motion, an object moves fastest when it's closest to what it's orbiting. For Parker, on December 24, 2024, that meant hitting a record-breaking speed of approximately 430,000 miles per hour, around 692,000 kilometers per hour, which is roughly 192 kilometers per second. Let's pause on that number. 430,000 miles per hour. That's fast enough to get from D.C. to Philadelphia in less than a second. It's more than 11 times faster than Voyager 1. This is our champion, the pinnacle of speed. So let's imagine we could point it not at the Sun, but out towards Andromeda. We have our speed, 192 kilometers per second. We have our distance, 5 million light-years, which is about 37 times 10 to the 19 kilometers. The math is simple division, but the answer is anything but. 37 times 10 to the 19 kilometers, 192 kilometers per second, gives you about 23 times 10 to the 17 seconds. Let's convert that into something a human brain can process. With about 5 million seconds in a year, the journey time becomes devastatingly clear. It's approximately 9 billion years. Just let that number sink in. 900,000,000 years. And that's just to get there. Our planet is only about 5 billion years old. This one-way trip would take almost as long as our world has existed. If the sheer cosmic scale of this fascinates you, and you want to keep exploring the mind-bending realities of our universe, take a moment to subscribe. Because we're about to go much deeper into why this number makes an intergalactic journey a one-way trip into oblivion. The billion-year glitch. A journey of 9 billion years isn't just a long trip. It's a geological and cosmological epic. The person, or machine, that arrives at Andromeda would have zero connection to the civilization that launched it. The very concept of home would have evaporated over eons. Let's walk through what happens during your 9 billion year flight. After the first million years, a tiny fraction of your trip, humanity as you know it would be unrecognizable, if we even exist at all. Our species has only been around for about 300,000 years. Evolution doesn't stop. Fast forward 250 million years. You're still less than 7% of the way there. Back on Earth, the continents have rearranged themselves into a new supercontinent. The planet would look alien. 1 billion years in. You're not even halfway there. And back in our solar system, the Sun's evolution is becoming a problem. As it ages, it gets brighter. In about 1 billion years, the Sun's luminosity will have increased by about 10%, enough to trigger a runaway greenhouse effect on Earth. The oceans will boil, and our planet will become a scorching, sterile rock like Venus. Your home is now dead. Finally, after 9 billion years, your ship arrives. You made it. But what's left? Earth is a cinder. And your journey isn't even over. because you still have to slow down, which requires just as much energy as getting up to speed in the first place. But let's ignore that and consider the most devastating, cosmic irony of all. At around the 4.5 billion year mark, something spectacular happens back home. The Andromeda galaxy, your destination, is on a collision course with the Milky Way. They're hurtling towards each other and will begin to merge, ripping each other apart and reforming into a new galaxy nicknamed Milkomeda. You left to go to Andromeda, but in a cruel twist, Andromeda was coming to you all along. You are a traveler without a destination and, most certainly, without a home. A return trip is a logical absurdity. Return to what? To where? Your starting point doesn't exist anymore. The unbreakable laws of physics. Right about now, sci-fi fans are probably yelling, but what about going faster? Closer to the speed of light? Time dilation? Fair questions, but the universe has answers, and they're not the ones we want. Problem 1. The ultimate speed limit. The most famous barrier is the speed of light. Einstein's theory of special relativity showed that as an object with mass goes faster, its mass effectively increases. As you approach the speed of light, the energy needed to go even a tiny bit faster skyrockets towards infinity. To get even a single atom to exactly the speed of light would require an infinite amount of energy. So when a spaceship jumps to light speed, in a movie, it's doing something as impossible as making a square circle. It's not an engineering challenge, it's a hard no from the cosmos. Problem 2. The cruel hope of time dilation. But wait, you say, time dilation. And you're right, it's real. As you approach light speed, your personal time slows down relative to a stationary observer. If you could travel to Andromeda at, say, 999% the speed of light, the journey might only take a few decades for you. You could survive it. This seems like a cheat code, but it's a cruel trick of perspective. While a few decades pass for you, 2.5 million years still pass for the universe you left behind. You would arrive, young and healthy, to an Earth that is 2.5 million years older. Your family, your civilization all gone. You'd be a temporal castaway, an alien in your own future. So yes, time dilation lets you survive, but it severs your connection to your origin. When you return, 5 million years will have passed on Earth. The trip is still one way. Problem 3. The tyranny of the rocket equation. Let's just talk mechanics. Getting anywhere fast requires a lot of energy, but the bigger problem is that the fuel itself has mass. This is the Tsiolkovsky rocket equation. To accelerate your ship, you need fuel. But to accelerate that fuel, you need more fuel, and so on, in a vicious exponential cycle. For a round trip to Andromeda, the numbers become comical. You need fuel to accelerate, fuel to decelerate at your destination, fuel to accelerate for the trip home, and fuel to decelerate again. Even with a perfect matter-antimatter engine, the initial mass of your ship would have to be astronomical. We're talking about a fuel tank the size of a planet just to push a small ship across the void and bring it home. Problem 4. The emptiness is dangerous. Finally, there's the journey itself. Intergalactic space is called the void for a reason. It is one of the most hostile environments imaginable, filled with high-energy cosmic rays. Over millions of years, this radiation would be devastating to both crew and electronics. Shielding against it adds mass, which brings us right back to the rocket equation problem. Then there's the dust. At relativistic speeds, even a speck of sand hits with the energy of a bomb, capable of vaporizing part of your ship. There is no calling for help. There's only you, your ship, and the endless, hostile dark. The fantasy of shortcuts. So if conventional travel is out, what about sci-fi's favorite loopholes, wormholes and warp drives? The Alcubierre warp drive is a neat mathematical idea. You don't move the ship through space, you move space itself around the ship by compressing it in the front and expanding it in the back. The problem? To do this, you need exotic matter, with negative mass or negative energy. We have never observed this stuff. Even if we could make it, early calculations suggested you'd need the energy equivalent of the entire mass of Jupiter. Then there are wormholes, or Einstein-Rosen bridges. These are hypothetical tunnels through space-time that could create a shortcut across the universe. But for a wormhole to be stable enough to pass through, it would need to be propped open. And the substance required to do that is, you guessed it, exotic matter with negative energy. These ideas are tantalizing, but they remain purely theoretical. Relying on a warp drive to get to Andromeda is like a 15th-century shipbuilder hoping to cross the Atlantic on a magical flying carpet. It's a leap of faith, not a technological roadmap. The dream of intergalactic travel speaks to our deepest nature as explorers. We look at the Andromeda galaxy, a swirl of 100 billion stars, and we want to go. But the universe, in its majestic indifference, says no. The distances are too great, the energy demands are infinite, and the laws of physics build a fortress around our galaxy. A journey to another galaxy is an act of permanent exile. It's a one-way trip, not just through space, but through time. The price of the ticket is everything you've ever known, your world, your history, your species. You would be a ghost haunting a future you were never meant to see. And yet, there is a strange beauty in this impossibility. It forces us to look back at ourselves. If this corner of the universe is our permanent home, then it's infinitely more precious. Our planet isn't a starting point to be abandoned, but a unique and irreplaceable sanctuary. The light from Andromeda will continue its million-year journey to our eyes. It serves not as a destination, but as a reminder of the incomprehensible scale of the cosmos, and of our own small, miraculous place within it. The galaxies are beautiful, but they are a sight to be cherished from afar. They are eternal goodbyes, painted across the night sky. Part 2. How far away another galaxy really is. If you could somehow leave Earth tonight, drift past the Moon, cross the orbit of Mars, and continue beyond every planet we have ever known, it would still feel, in cosmic terms, as though you had barely stepped out of your front door. That is the quiet truth at the center of intergalactic travel. The problem is not simply that another galaxy is far away. It is that, far away, stops meaning anything useful once you begin to measure the real scale of the universe. Human beings are good at understanding the sizes of rooms, cities, countries, and even planets. We can picture a road trip. We can picture a flight across an ocean. We can even, with a little effort, picture the distance to the Moon. But galaxies live in a different category of reality. Their distances are so vast that the mind does not really absorb them in a single glance. It has to approach them slowly, almost gently, layer by layer, like eyes adjusting to darkness. So before we can understand why visiting another galaxy would be a one-way journey, we have to do something simpler. We have to feel the distance. Not calculate it. Not just say the number and move on. We have to feel what it means. That is harder than it sounds, because our instincts were never built for this. They were built for forests, weather, daylight, footsteps, and seasons. They were built to judge how far a river is, or how long it takes to walk home before sunset. They were not built to understand a place so distant that its light began traveling toward us before human civilization existed in any recognizable form. And yet, that is exactly what we are trying to do. So let us begin where every human journey begins, close to home. The Moon feels far away to us. On average, it sits about 384,000 kilometers from Earth.
That is far enough that even light, the fastest thing in the universe, still needs a little over 1 second to get there. When the Apollo astronauts traveled to the Moon, it took them roughly 3 days. 3 days just to reach the nearest world beyond our own. That already feels large. 3 days through empty space to the closest natural object in the night sky. Then there is the Sun. The Sun is not a little farther than the Moon. It is vastly farther. About 150 million kilometers away. Light from the Sun takes around 8 minutes to reach Earth. Every sunrise you have ever seen is slightly delayed. The warmth on your skin is old news by the time it arrives. Even inside our own solar system, time has already begun to stretch. And yet the Sun still belongs to our immediate neighborhood. It is, in a very real sense, our local fire. Move farther out, and the scale becomes stranger. Jupiter, the giant of our solar system, is so distant that sunlight takes tens of minutes to reach it. Neptune is so far from the Sun that sunlight there is not bright and warm in the way we know it. It is faint, thin, and cold. Pluto, when it is nearest the Sun, is still billions of kilometers away. And even Pluto is not the true edge of our solar system. It is only one lonely marker in a much larger wilderness. Beyond Pluto lies the Kuiper Belt, a scattered zone of icy bodies. Beyond that, perhaps much farther still, lies the Oort cloud, a vast spherical shell of icy remnants thought to surround the solar system at enormous distances. If the inner planets are like the rooms of a house, then the Oort cloud is more like a boundary lost somewhere in the fog, so far away that the Sun itself would look only like a very bright star. And this is an important moment to pause, because many people grow up with the quiet impression that the solar system is the main thing, the great expanse, the big map of space. It is not. The solar system is tiny. Beautiful, yes. Immense by human standards, of course. But tiny in the larger architecture of the galaxy. That is where the real change in scale begins. If you leave the Sun behind and head toward the nearest star, Proxima Centauri, you are no longer traveling between planets. You are crossing the dark sea between stars. And that nearest star is about 24 light-years away. A light-year is not a measure of time, even though it sounds like one. It is a measure of distance. It is the distance light travels in 1 year, moving at about 300,000 kilometers every second. In 1 second, light could circle Earth several times. In 1 year, it travels nearly 9.46 trillion kilometers. That is 1 light year. Proxima Centauri is more than 4 of those away. This is where even familiar numbers begin to lose their grip. 1 million kilometers no longer helps. 1 billion kilometers no longer helps much either. You begin needing new language, because ordinary distance units become too small, like trying to measure the width of an ocean with a ruler. And yet, in galactic terms, Proxima Centauri is still right next door. The stars you see in the night sky are not arranged like streetlights in a town. They are scattered through depth. Some are relatively near. Many are vastly farther away than they appear. The sky flattens them into a dome, but that is an illusion of perspective. In reality, space has thickness. It has layers. It has emptiness so wide that even the nearest stars are separated by unimaginable gaps. This is what makes interstellar travel so hard. Not because stars are exotic, but because they are lonely. They live far apart. The Milky Way is not crowded in the way our eyes suggest. It is mostly absence, mostly dark, mostly distance. Now let us widen the frame. The Milky Way, our home galaxy, is itself enormous. It contains hundreds of billions of stars. Estimates vary, but a common range is roughly 100 to 400 billion. Our Sun is just one of them. One ordinary star in one spiral galaxy among many. And the Milky Way is not a small galaxy. It stretches roughly 100,000 light-years across, perhaps more depending on how one defines its outer regions. That means that if you could travel at the speed of light itself, which we cannot, it would still take about 100,000 years to cross the galaxy from one side to the other. Pause there for a moment. Even light needs 100,000 years to cross our galactic home. Human civilization, from the first cities to the digital age, is only a tiny fraction of that span. Agriculture began around 10,000 years ago. Written history, in its familiar form, spans only several thousand years. A beam of light crossing the Milky Way would still be traveling long after all of recorded human history had come and gone many times over. So when we talk about visiting another galaxy, we are not talking about stepping beyond our backyard fence. We are talking about leaving one vast city of stars and crossing the wilderness between cities. That wilderness is where the scale becomes truly severe. Our nearest large galactic neighbor is Andromeda, the great spiral galaxy sometimes visible to the naked eye as a faint blur in dark skies. It is about 2.5 million light-years away. 2.5 million. That number matters because of what it means. The light reaching your eyes from Andromeda tonight left that galaxy around 2.5 million years ago. When that journey began, Earth was not empty, but it was ancient beyond anything that feels human. No cities, no writing, no language in the form we know it, no architecture, no memory preserved in books or stone. Early human ancestors were still far from becoming what we are now. And that is the light, not a spaceship. Not matter with engines, fuel, shielding, and fragile biology inside it. Just light. This is why another galaxy feels almost mythical. The image in the sky looks calm and close enough to point it, but what you are seeing is a signal from deep time. Andromeda is not simply far across space. It is also far across history. The more you sit with that, the stranger it becomes. Imagine drawing a map of your life. Your home, your school, your job, the streets you know, maybe the airport you have flown from, maybe a few countries you have visited. Then imagine zooming out to include Earth, then the moon, then the planets, then the sun as one star among many, then the Milky Way as one galaxy among others. At each step, the previous map becomes smaller, until eventually everything familiar shrinks into something almost too small to name. That shrinking is not only physical, it is emotional too. Because another galaxy does not merely challenge our technology, it challenges our sense of place. We like to think of ourselves as mobile creatures, explorers, beings who can push past every frontier. And in many ways, we are. We crossed mountains, oceans, deserts, and skies. We stepped onto another world. We sent machines beyond the planets. These are real triumphs, beautiful ones. But galaxies remind us that movement has limits. Not moral limits, not imaginative limits, physical limits. The universe allows beauty. It does not always allow access. Sometimes the most important thing about a distant object is not that it exists, but that it may remain forever out of reach in any ordinary human sense. And this is where analogies can help, even if they always fail a little. Suppose the distance from Earth to the Sun were reduced to about 1 meter. A comfortable step. On that scale, Neptune would still be far out in the distance, and the nearest star would be tens of thousands of kilometers away. Another galaxy would be so far away that the analogy itself starts to break. It would no longer feel like a household model. It would feel planetary. Or imagine Earth as a grain of sand. The Sun would be another grain some distance away. The solar system would become a sparse little arrangement. The nearest stars would not be in the same room. They would not even be in the same building. And another galaxy would not be across the city. It would be beyond the map you started with. This is why the phrase, the nearest galaxy, is quietly misleading. It sounds as if there is comfort in the word nearest, as if proximity solves something. It does not. The nearest galaxy is still staggeringly far. And even Andromeda, as huge and dramatic as it is in our imagination, is only part of our local group, a small gathering of galaxies bound together by gravity. The local group itself includes the Milky Way, Andromeda, the Triangulum Galaxy, and many dwarf galaxies. Even here, in our local cluster of galactic neighbors, distance remains immense. Beyond the local group lie larger collections of galaxies, then clusters, then superclusters, then the great cosmic web, where galaxies are strung across the universe in filaments and vast empty regions. The more we discover, the more the universe seems to say the same thing in different forms. There is structure, there is beauty, and there is a great deal of emptiness between the islands of light. This emptiness matters, because people often imagine space as crowded with destinations. But space is not crowded. It is sparse. It is mostly dark with rare pockets of brilliance. Stars are not stepping stones laid out for easy passage. Galaxies are not close neighbors chatting across a fence. They are colossal systems divided by gulfs that are almost difficult to describe without sounding poetic. But this is not poetry. It is measurement. And once you understand that, something changes in the whole idea of travel. Travel on Earth usually means going from one dense region of life to another, one city to another city, one airport to another airport. Even crossing an ocean, you remain within a biosphere, inside a world full of air, weather, gravity, water, and history. The whole journey takes place within a single living system. Intergalactic travel is not like that at all. It is not going from one city to another. It is leaving a city, then crossing a nearly incomprehensible desert of darkness so vast that even our galaxy, immense as it is, becomes only the place you departed from. And the place you hope to reach remains a faint arrangement of light ahead, separated not just by distance, but by deep time. This is why the one-way feeling begins here. Before we even start talking about engines or human survival, it begins with scale itself. Because scale changes the meaning of return. A short trip has a natural structure. You leave, arrive, stay, and come back. A longer trip stretches that pattern, but it remains familiar. You can still imagine home waiting for you, unchanged enough to recognize. But when the distance grows beyond all human timescales, that structure begins to fail. Even before we talk about relativity, fuel, radiation, or life support, sheer distance has already started to dissolve the old idea of a journey. It is no longer leave and come back. It becomes leave and continue. Leave and disappear into the future. Leave and arrive in a reality so distant from your starting point that home becomes less a location and more a memory. That is what galaxies do to the concept of travel. They turn movement into exile. Not because anyone intended it, but because the universe is large in a way our emotions do not naturally account for. And maybe that is part of why galaxies have always felt so haunting. When you look at one, you are seeing something undeniably real, and yet already old by the time it reaches you. It is present to your eyes and absent from your moment. Near in appearance, unreachable in fact. It is both visible and untouchable. A kind of cosmic paradox. And still, there is something deeply peaceful in facing that honestly. Because once we stop pretending the universe is scaled for our convenience, we begin to appreciate what is actually here. This one star. This one world. This one galaxy that has carried us from ancient oceans to radios, telescopes, and thought itself. The Milky Way stops feeling like the place we are trapped in, and starts feeling like the home we were lucky enough to awaken inside. If this quiet journey through the scale of the cosmos is helping you unwind, you can leave a like, subscribe to the channel, or simply stay with the sound of it. And if you feel like sharing, I'd love to know what object in space makes you feel the smallest when you think about it. Because perhaps that is the real lesson of galactic distance. Not just that another galaxy is far away, but that distance itself changes us when we truly let it in. It humbles the traveler. It softens the ego. It reminds us that the night sky is not a ceiling decorated for our entertainment, but a window into a reality so large that even our boldest dreams must slow down and become more honest. And from that honesty, a new kind of wonder appears. Not the wonder of conquest. Not the wonder of claiming every destination, but the wonder of seeing clearly. Another galaxy is not just a destination on a map. It is a test of what we mean by distance, by time, by leaving, and by returning. It forces us to admit that some lights in the sky are not invitations in the ordinary sense. Some are messages from afar. Some are monuments to scale. Some are reminders that the universe can be breathtaking without being accessible. And perhaps that is enough. Perhaps enough, for now, is to lie here beneath our own galaxy, feel the quiet truth of the numbers, and understand that when we say another galaxy is far away, we are saying something much deeper than we usually mean. We are saying that the universe is wider than our instincts. That light itself grows old on the journey. That home is smaller, rarer, and more precious than it first appears. And that once you try to cross from one galaxy to another, you are no longer just traveling through space. You are traveling beyond the comfortable scale of human life itself. That is the real distance.
And it is only the beginning.
Part 3. Why crossing even our own galaxy is already so hard? It is tempting to think the real problem begins only when we leave the Milky Way behind. As if our own galaxy were the manageable part, and the impossible part only starts once we aim for somewhere beyond it. But the quiet truth is more unsettling than that. You do not need to travel to another galaxy to run into the limits of distance. You only need to try crossing your own. Because long before intergalactic travel becomes a problem, interstellar travel already breaks the old human idea of a journey. And once you see that clearly, the dream of casually visiting another galaxy begins to change shape. It stops looking like a grand extension of exploration and starts looking like something else entirely. Something colder. Something slower. Something so stretched by time and distance that even going somewhere no longer means what it used to mean. So for a little while, let us stay at home. Not on Earth, but in the Milky Way. Because before we can understand why another galaxy would be a one-way trip, we have to understand a quieter fact first. Our own galaxy is already so vast, so sparse, and so difficult to cross that it almost behaves like many separate worlds stitched together by darkness. When we look up at the night sky, it can feel crowded. Stars are everywhere. Tiny points scattered across the dark, as if space were full of nearby destinations waiting patiently for us. But this is one of the oldest illusions the sky gives us. The stars do not look far apart because our eyes flatten them. They remove depth. They turn a three-dimensional wilderness into a two-dimensional ceiling. In reality, the Milky Way is not crowded in the way it appears. It is mostly emptiness. Even in our own stellar neighborhood, the distances are severe. The nearest star beyond the Sun, Proxima Centauri, sits more than 4 light-years away. That may sound almost familiar now, after hearing numbers like millions of light-years. But familiarity can be misleading. 4 light-years is still a distance so enormous that human language tends to glide over it too quickly. If you could travel at the speed of light, the absolute speed limit of the universe, you would still need more than 4 years to get there. And we cannot travel at the speed of light, not even close. This matters because it means the nearest star is not nearby in any practical human sense. It is not next door. It is not even in the next town. It is separated from us by a gulf so wide that all of recorded history becomes small beside the problem of crossing it. And Proxima Centauri is not some distant edge case. It is the closest target we have. The simplest trip out of our local cosmic neighborhood is already beyond anything humanity has ever done, and beyond the lifespan of any ordinary human life. That is where the real weight of galactic distance begins to settle in. Because once the nearest star is that far away, everything else inside the galaxy starts to unfold in a new light. Our Sun lives in a minor spiral arm of the Milky Way, often called the Orion Arm or Orion Spur, a relatively modest region between larger spiral structures. We are not at the center of the galaxy. In fact, we sit roughly 26 to 27,000 light-years from the galactic center, orbiting in the quieter suburbs of this vast stellar city. That means if someone imagined a mission not to another galaxy, but merely to the center of our own, they would already be proposing a journey tens of thousands of light-years long. Again, if you could move at light speed, which you cannot, it would still take tens of thousands of years. And the Milky Way itself stretches roughly 100,000 light-years across, perhaps more depending on where you place its dimmer outer boundary. So even the idea of crossing from one side to the other becomes an almost geological undertaking. Human history would be gone many times over before light itself completed the trip. It is worth lingering on this, because the phrase, our galaxy, sounds intimate. It sounds singular, like a coherent place. But the Milky Way is less like a country and more like a continent of continents, a structure so enormous that two stars within it may be functionally isolated from one another for all practical purposes. When people first hear this, there is often a kind of quiet shock, because we grow up with maps. Maps of neighborhoods, nations, oceans, planets, even the solar system. And maps give a comforting feeling. They suggest scale can be understood, routes can be planned, and destinations can eventually be reached. But a galaxy resists that comfort. A galaxy is too large to be held in the same mental frame as an ordinary trip. You can draw it, label it, animate it, and still not really feel what it means to move through it. A line across a diagram is not a journey. It is a symbol for one. The journey itself would be something else entirely. Imagine leaving Earth and heading not for another galaxy, but for a star just a few hundred light-years away. That sounds, by galactic standards, modest. A short hop, almost. Yet even that distance would carry you farther than any human or machine has ever gone by an absurd margin. A few hundred light-years means that even light would need centuries to make the trip. A message sent from Earth would not arrive until everyone who sent it had long since died. A reply would come back to descendants so distant they might not even remember the question in the same way. Conversation would dissolve. Coordination would dissolve. The living thread between departure and origin would begin to fray. And that is only a few hundred light-years. The galaxy teaches a cruel lesson very early. Distance does not simply separate places. It separates moments. It separates generations. It separates meanings. On Earth, a journey is usually still held together by shared time. Even when travelers go far away, there is still a basic continuity. Letters arrive. Calls are made. The place you left behind is still happening alongside you. It remains part of your world. Inside a galaxy, once the distances become large enough, that continuity begins to break. Not because of war or disaster, but because light itself is too slow to keep life synchronized across such scales. This is one of the strangest things about space. The fastest thing in the universe is still not fast enough to preserve ordinary human relationships over galactic distance. A civilization spread across the Milky Way would not feel like a single tightly connected society. It would feel fragmented by time. One region would always be learning old news from another. Decisions, discoveries, warnings, even greetings would arrive late, carrying the texture of the past with them. And if communication already becomes this strained, then travel becomes something even more extreme. Because travel is not just sending information, it is sending matter. A ship, a body, a fragile system that must survive the silence between stars. This is where another illusion quietly disappears. We often imagine stars as though they were part of a natural route, like islands across a sea. But the stars are not arranged for our convenience. They are not stepping stones laid out in neat intervals. They are sparse and lonely, separated by distances that make each crossing feel less like a voyage and more like a leap into absence. Even in the denser parts of the galaxy, stars are tiny objects compared to the vast volumes between them. If you could shrink the sun to the size of a grain of sand, the nearest stars would still be far away across a space that no longer felt intimate or navigable. They would not form a welcoming chain. They would form a pattern of remote, disconnected lights. And the further you imagine going, the more severe that reality becomes. Suppose a mission set out to reach a star 1,000 light-years away. Not another galaxy. Not the edge of the Milky Way. Just one star among many within our own galactic home. 1,000 light-years is still only about 1% of the Milky Way's width, and yet it would already be enough to completely destroy the old idea of a round trip. Even if a ship could somehow move at a meaningful fraction of light speed, the travel time would stretch across generations. The people who launched the mission would never see its return. The culture that sent it might not survive long enough to interpret its results. Languages could shift. Values could change. Entire civilizations could rise and fall while the ship remained in transit. At that point, the word expedition begins to feel too light. What you are really describing is not a trip, but a transfer of existence from one era into another. And this is still happening within one galaxy. There is also a psychological side to this that often goes unspoken. Human beings are deeply shaped by cycles we barely notice. Day and night, weather, seasons, the changing angle of sunlight, familiar gravity, shared clocks, the ordinary presence of a living world. Even people who spend time in remote places on Earth still remain inside a biosphere, inside a moving sky, inside a world full of signs that life is nearby. Crossing the galaxy would strip almost all of that away. For years, decades, or longer, depending on the mission, there would be no landscape, no horizon, no weather, no sunrise in the ordinary sense. Perhaps only the engineered interior of a ship and the deep black outside. Stars ahead, stars behind, and distance expanding in every direction. The journey would not merely be long. It would be monotonous in a way that Earth never is. A silence so complete that it would start to feel like an environment of its own. And even this description may be too gentle, because silence sounds peaceful. In truth, the problem is not peacefulness. It is scale combined with isolation. It is the knowledge that every course correction, every technical failure, every human emotion, every need for repair would happen inside a void that does not forgive mistakes and does not offer shortcuts. If this calm walk through cosmic distance is helping you settle in, you can leave a like, subscribe, or simply stay with the story. And if you want to add a thought of your own, I'd be curious to know what feels harder to imagine, the distance between stars, or the silence between them. Because in many ways, that silence is part of the difficulty too. The Milky Way is not a solid object. It is not a dense wheel you can push through with enough effort. It is a pattern of matter moving through darkness. Everything inside it is in motion. Stars orbit the galactic center. Clouds drift. Gravitational relationships shift slowly over time. A target is never perfectly still. A ship would not simply aim and go. It would have to navigate a moving environment over immense timescales, where the map itself slowly changes while you travel through it. And there is a deeper emotional consequence to that. The farther you go, the less your departure point remains the place you imagined leaving. Earth is not standing still while you travel. The Sun is orbiting the center of the galaxy at hundreds of kilometers per second. The galaxy itself is moving relative to others. Every destination and every home are in motion at once. So even within the Milky Way, travel is not a matter of moving across a stable backdrop. It is a matter of threading a course through a dynamic system whose true scale is too large for instinct and too slow for intuition. This is why the galaxy already defeats the casual fantasy. In films, a starship leaves one star system and arrives at another as though crossing between neighborhoods. The transitions are quick because the human mind needs continuity. Stories need rhythm. Characters need scenes to return to. But the actual galaxy does not care about narrative convenience. It stretches every transition until ordinary storytelling begins to fail. What does it even mean to depart for a place you will never see as a completed journey in any familiar human framework? What does it mean to say goodbye when the travel time is longer than the life of nations? What does mission success mean when the original mission planners are dust before the halfway mark? These are not just engineering questions. They are questions about identity, inheritance, and whether human language can carry the emotional weight of distances it was never meant to describe. And perhaps that is why galaxies feel both beautiful and slightly sorrowful. Because once you truly understand their size, you realize that most of what they contain is not available to us in the way mountains, oceans, and even planets are. We can observe them, measure them, model them, wonder about them. But access is another matter entirely. The galaxy is full of stars, and still it is mostly unreachable. Not in principle, perhaps. Not forever, if one wants to leave room for futures we cannot yet see. But certainly not in the old, comfortable human sense of going and returning with stories to tell around a living fire. The Milky Way already asks too much of the traveler. It asks for time measured not in months or years, but in lifetimes and civilizations. It asks for patience beyond biology. It asks for machines that do not merely work, but endure. It asks for meaning that survives generational delay. It asks for a form of commitment so absolute that once you say yes, you may already be surrendering the world that made the journey meaningful in the first place. And that is only within our own galaxy. We have not even crossed the dark between galaxies yet. We have only walked to the edge of our own home and looked around carefully enough to realize how large that home really is. This is the bridge between fantasy and physics. Before we ask how to reach another galaxy, we have to admit that our own galaxy is already enough to humble us. Already enough to force the old explorer's dream into a new shape. Because a galaxy is not just big. It is big in a way that changes the meaning of action. A short distance invites movement. A longer distance demands planning. But a galactic distance transforms movement into legacy, into generational intention, into a kind of one-way unfolding through time. That is why this matters so much for the larger question. If crossing a small fraction of the Milky Way is already an undertaking so extreme that it breaks ordinary ideas of travel, then visiting another galaxy is not simply more of the same. It is a different order of impossibility layered on top of the first. First you lose the easy meaning of distance. Then you lose the easy meaning of time. Then, slowly, you lose the easy meaning of return. And in that sense, the one-way nature of intergalactic travel does not begin out there in the vast dark between galaxies. It begins here, inside the Milky Way, the moment we honestly admit what even our own home already demands of anyone who tries to cross it. So perhaps the deepest lesson of this part of the journey is a quiet one. Home is larger than we thought. The galaxy that cradles our sun is not a local backdrop. It is an empire of distance, a cathedral of scattered light, a place so wide that even to move within it is to enter a new relationship with time, isolation, and patience. And if that is true of home, then the space beyond home is not just far. It is almost beyond the old human meaning of far. Which is why, before we talk about the engines that might carry us outward, we first have to sit with this simpler, heavier truth. Crossing even one galaxy is already hard enough to change everything. Part 4: Why our fastest spacecraft are still nowhere near fast enough. There is a quiet comfort in the idea that every hard problem can eventually be solved by building a better machine, a stronger engine, a lighter material, a smarter design. It is one of the deepest habits of the modern mind. When something seems impossible, we often assume it only means we are still early, still primitive, still waiting for the next invention. And on Earth, that habit has served us well. Ships became steamships. Steamships gave way to aircraft. Aircraft gave way to rockets. Distances that once consumed months now disappear in hours. So it is natural, almost inevitable, to look at the stars and think in the same way. We imagine that the problem of reaching another galaxy is simply a problem of patience and engineering. Not impossible, just not yet solved. But space has a way of humbling that instinct. Because when it comes to other galaxies, the problem is not that our ships are a little too slow. It is that they are slow in a way that barely feels like motion at all when measured against cosmic distance. The gap between what we can do and what we would need to do is not a gap of one generation of technology. It is a canyon. And if we are honest about that canyon, then the dream begins to change. Not vanish, perhaps, but change. To understand why, we have to begin with something deceptively simple. Speed only makes sense when compared to the distance you are trying to cross. A bicycle is slow across a country. A jet is slow across the solar system. And a rocket, even a very fast one, is slow against the scale of galaxies in a way that is difficult to feel until you sit with the numbers long enough for them to stop sounding abstract. On Earth, we celebrate speed in dramatic units. Hundreds of kilometers per hour. Thousands. Mach numbers. Escape velocity. Orbital velocity. These are real achievements. Astonishing ones. To leave Earth at all is one of the most extraordinary things our species has ever done. Every rocket launch is, in its own way, a small miracle of calculation, fire, and timing. But space is patient. Space does not care how impressive a speed sounds to creatures who evolved walking across grass. What matters is not whether a spacecraft is fast by human standards. What matters is whether it is fast enough for the distance ahead. And very quickly, the answer becomes no. The spacecraft that humans have built are remarkable, but they are built for a very different kind of journey. They are built for planets, moons, flybys, probes, orbital insertions, maybe one day for deeper travel across the solar system. Even our boldest real machines still belong to the age of the local neighborhood. They are not interstellar tools in any practical sense, and they are certainly not intergalactic ones. It is easy to be misled here, because the raw speeds are genuinely enormous. Some spacecraft move faster than bullets, faster than anything we have known on Earth outside a launch trajectory. They can cross continents in moments. They can escape Earth's gravity. They can leave the planets behind. But leaving the planets behind is not the same as becoming fast on a galactic scale. That is the key shift. A spacecraft can be fast enough to astonish us and still be, in the larger frame, almost still. Imagine an ant walking across a football field. Now imagine a tiny increase in its pace. To another ant, that might seem dramatic. But from the perspective of an airplane crossing oceans, both speeds are essentially the same. The difference matters locally. It disappears at larger scales. Something like that happens when we compare our rockets to the Milky Way, and then to the void between galaxies. Even the fastest craft we have launched are moving at only a tiny fraction of the speed of light. Tiny enough that light itself, which already takes years to cross even modest interstellar distances, remains in an entirely different category of travel. This is where people often say, quite reasonably, then why not just build something much faster? And that is exactly the right question. Because once you ask it seriously, you begin running into the hard edges of physics. The first problem is that rockets do not simply move because you wish them to. They move by throwing mass in the opposite direction. That is the heart of rocket propulsion. You expel propellant backward, and the rocket moves forward. It is elegant, brutal, and costly. Every gain in speed has to be paid for by carrying the means to produce it. And this creates one of the most unforgiving loops in engineering. If you want to go faster, you need more fuel. But more fuel means more mass. And more mass means you need even more fuel to move the fuel you already added. That is the trap. It does not grow linearly. It grows in a way that becomes punishing very quickly. A little more speed may require not a little more fuel, but vastly more. At some point the vehicle begins to look less like a ship carrying fuel, and more like fuel carrying a ship. This is one reason interplanetary missions are already hard. Engineers fight for every kilogram. Every instrument, every heat shield, every component must justify itself. Weight is not just an inconvenience. It is destiny. Now imagine trying to scale that problem from a trip to Mars to a trip between stars. Then from stars to galaxies. The difficulty does not merely increase. It begins to turn strange. Chemical rockets, the kind that lifted humans to the moon and launched countless missions beyond Earth, are powerful enough to escape gravity wells and move around the solar system. But they are nowhere near what would be needed for interstellar travel in a humanly meaningful timeframe. They carry a lot of force for a short time, which is wonderful for launch, but their exhaust speeds are simply too low for the kind of sustained, enormous delta V that deep interstellar journeys would demand. And that phrase, delta V, though technical, points to something simple. It is the total change in velocity your mission can achieve, your real motion budget, your ability not just to leave, but to adjust, to accelerate, to slow down, to arrive without becoming a projectile that screams past the destination at impossible speed. Because that is another quiet trap in these conversations. People often imagine getting there, but they do not always imagine stopping. To reach another star, let alone another galaxy, you do not merely need to accelerate. You need to survive the long journey, then decelerate at the end. Otherwise you are not arriving. You are passing through. And any speed you gain on the outbound leg becomes a debt you must pay later if you want to stop. So the energy problem is not one problem. It is at least two. Go fast enough to cross the distance, then slow down enough to make the destination meaningful. Already, for stars, this is severe. For galaxies, it becomes crushing. Let us imagine, gently and without too much mathematics, what would count as a useful speed for interstellar or intergalactic travel. Not perfect, not magical, just useful in a way a human being might emotionally recognize as a journey rather than an inheritance project for distant descendants. You would need a spacecraft moving at a meaningful fraction of the speed of light, not 1% of everyday intuition, a real fraction of light speed, perhaps 10% or higher, before the timescales begin to feel remotely less impossible. 10% of light speed is an absurdly large number in engineering terms. It is not a small improvement over present-day spacecraft. It is a leap into another era of propulsion entirely. And even that would not solve the galaxy problem in a satisfying way. At 10% of light speed, a single light year takes about 10 years to cross, not counting acceleration and braking. The nearest stars would still be a long commitment. The Milky Way would still be immense beyond comfort. And another galaxy would remain so distant that the language of travel begins to break again. So when we say our rockets are not fast enough, we do not mean they are behind schedule. We mean they belong to a different class of possibility. They are tools for local space. And there is no shame in that. It is already extraordinary that primates on one rocky planet learned to build machines that can leave their world. But honesty matters. A deep space probe is not one evolutionary step away from becoming an intergalactic ship in the way a propeller plane became a jetliner. The scales are too different. There are other ideas, of course. Nuclear propulsion, fusion propulsion, beam-driven sails pushed by powerful lasers, antimatter in theory. These are fascinating concepts, and some of them may one day transform what is possible within the solar system or even toward nearby stars. They deserve wonder and serious thought. But even those ideas do not make the core problem disappear. They merely move the line. And when the line is another galaxy, moving the line is not the same as crossing it. Fusion, for example, if humanity ever masters it reliably for propulsion, could in theory offer much greater energy density than chemical fuel. A fusion-driven craft might one day achieve speeds that make today's rockets look quaint. But greater is not the same as enough. Even then, carrying fuel, managing heat, maintaining systems, shielding a craft, and handling deceleration over extreme timescales would remain immense challenges. Heat is its own quiet tyrant in all of this. We often think of space as cold, and it is. But engines are not. Powerful propulsion systems generate extraordinary heat, and in space, Shedding heat is harder than many people realize. On Earth, machines cool through air, convection, fluid systems, contact with a surrounding environment. In space, there is no air waiting to take your waste heat away. You radiate it, slowly, relentlessly. Your ship becomes not just a vehicle, but a balancing act between energy gained and heat survived. Then there is the question of structure. The faster you move, the more every problem becomes sharper. Tiny errors in alignment matter more. Tiny particles matter more. Tiny failures matter more. At sufficiently high speed, a collision with something as small as dust becomes a violent event. Space is empty, but not perfectly empty, and at extreme velocity even sparse matter becomes dangerous. So whenever we imagine a ship going much faster than anything we have ever built, we are not just imagining a better engine. We are imagining a whole new civilization of engineering, new materials, new thermal systems, new shielding methods, new approaches to reliability, redundancy, autonomy, and perhaps even the meaning of crewed travel itself. This is why the dream remains powerful but slippery. The sentence, "We just need faster rockets," sounds so reasonable, calm, practical, but underneath it sits a mountain of hidden difficulty. Faster by how much? Powered by what? For how long? With what mass? Against what heat? Toward what stopping point? Under what protection? And with what return? That last question matters more than it first appears. Because even if we solved the outward speed problem far better than we can now imagine, what would it mean to make the trip worth taking? A journey is not just a path through space. It is a relationship between departure and arrival, between leaving and meaning, between traveler and home. And speed is central to that relationship. If a trip takes too long, then even a technically successful mission starts to become emotionally unrecognizable as a journey in the old human sense. It becomes something else, a drifting handoff between eras, a mission launched by one world and received by another. In that sense, speed does not just determine duration. It determines whether return is still part of the same story. This is one reason the desire for near-light speed travel appears so often in science fiction. At an intuitive level, we understand that without truly extreme velocity, the distances win. Not gradually, completely. A slow starship is not merely inconvenient. It is existentially different from a fast one. And yet the universe guards high speed fiercely. Long before you reach the speed of light, the energy demands become enormous. Relativity begins to matter. Every additional gain costs more than the last. The cosmos does not hand out near light speed motion casually. It resists. Not emotionally, of course. Not personally. But structurally. As a fact of how energy and mass behave. And that brings us back to a quieter point that often gets lost beneath the spectacle of futuristic designs. The universe is not obligated to let travel remain easy as distances grow. That is perhaps the deepest reason our fastest spacecraft are nowhere near fast enough. Not because our engineers lack talent. Not because our generation lacks ambition. But because the scale of the problem rises into a region where cleverness alone stops being enough. There are frontiers where better design produces steady progress. And there are frontiers where the map itself changes. Intergalactic travel belongs to the second kind. By the time you begin imagining a ship truly fit to bridge the abyss between galaxies, you are no longer refining the rocket age. You are trying to step beyond it into something almost as conceptually different as a rocket is from a horse. If this slow walk through the physics of distance is helping you settle in, you can leave a like, subscribe to the channel, or simply stay here with the thought of it. And if you want to leave a comment, I'd love to know what feels more surprising to you, how fast our spacecraft already are, or how little that speed means once the universe gets involved. Because that contrast is the heart of the whole matter. Our machines are incredible. The universe is simply larger. And sometimes both truths must be held at once. There is no need to diminish human achievement to say this. Parker's solar probe is real. Voyager is real. Lunar landings are real. Orbital stations, planetary probes, telescopes unfolding in deep space, all of it is real and worthy of awe. But awe should not blur categories. Greatness within the solar system is not the same as readiness for the gulf between galaxies. We are still, in a very real sense, coastal sailors. Brave ones. Ingenious ones. But coastal sailors nonetheless. We have learned how to leave shore, how to circle nearby islands, how to navigate local waters. We have not yet built the vessel that can cross the cosmic ocean in a time that preserves the old human meaning of a round trip. And another galaxy lies not beyond the bay, but beyond oceans layered upon oceans. So by now, a difficult truth begins to settle over the journey. The one-way nature of visiting another galaxy is not only about distance in the abstract. It is about the brutal mismatch between cosmic scale and attainable speed. It is about how even our greatest machines, magnificent as they are, remain bound to a realm of travel that is still intimate compared to the map ahead. And once you understand that, the next question arrives almost on its own. Even if we could somehow keep improving, even if we could push farther and faster than anything now alive has seen, what would that speed mean against a human lifespan? Because a ship does not need to be merely fast. For the journey to feel like a journey at all, it must be fast enough for a person to live through it. And that is where the next layer of the problem begins. Part 5, the problem of human lifespan. Imagine being told that the greatest journey in history is ready. The ship is waiting. The engines have been checked. The course has been set. The destination is not a planet, not a nearby moon, not even a neighboring star, but another galaxy. A place so distant it has lived in the human imagination almost like a dream. And for one brief moment, the dream feels real. Then someone quietly hands you the travel time, and everything changes. Not because the number is large in the ordinary sense, but because it instantly reveals something deeper. The true obstacle is not only distance. It is not only speed. It is not only fuel, engineering, or physics. It is the fragile length of a human life. That is the part people often feel before they understand it. A galaxy is not just far enough away to challenge our machines. It is far enough away to challenge the very frame of human experience. We do not live long enough for such distances to remain journeys in the ordinary sense. We are creatures of decades. Maybe, with luck, a long handful of decades. Our memories, our relationships, our plans, our hopes, our grief, all of it is shaped by that span. Human life is long enough to love deeply, build slowly, learn difficult things, raise children, watch a city change, grow old, and leave behind a story. But it is not long enough to cross intergalactic space and come home as though nothing fundamental has been broken by the delay. And this is where the dream of visiting another galaxy starts to become something sadder and stranger than a challenge of transportation. Because once the journey stretches far beyond a human lifespan, it is no longer simply a question of how to get there. It becomes a question of who, exactly, is doing the going. If you leave Earth for a destination you will never live long enough to reach, are you truly traveling there in the old sense of the word, or are you only beginning a process someone else must finish? If your children continue the mission, and then their children, and then theirs, does the original traveler still meaningfully count as the traveler at all? At what point does a journey stop being a trip and become a chain of inheritance? These are not just poetic questions. They are part of the real problem. Because human travel, the way we naturally imagine it, carries an assumption that is so basic we barely notice it. The same person who leaves is expected, in some recognizable form, to arrive. That continuity matters. It is what makes a journey feel like a human experience instead of an abstract event. The traveler sees the departure, endures the middle, and witnesses the destination. That arc gives the journey emotional coherence. But across galactic distances, that coherence starts to collapse. Even interstellar distances begin to strain it. Another galaxy destroys it almost completely. This is why the lifespan problem sits at the center of the one-way story. We are not just talking about crossing space. We are talking about trying to preserve a human story across spans of time that do not belong to human life. And human life, for all its richness, is brief. That brevity is not a flaw. It is part of the shape of us. We experience seasons because we live through many of them, but not endlessly many. We make plans because time is limited. We love urgently because loss is inevitable. We care about home because our lives are finite enough for place to matter. Mortality gives human life a kind of contour. It makes things precious. But it also means that certain distances in the universe do not simply lie beyond our technology. They lie beyond the narrative scale of our bodies. A person can leave home for years and still return meaningfully. A soldier, a sailor, a migrant, an explorer, even an astronaut can cross a difficult absence and come back to a world that still remembers their name. Time has passed, yes, but not so much that identity itself dissolves. The thread remains intact. Now imagine leaving for centuries. Already the thread begins to fray. Leave for millennia, and it is gone. Leave for millions of years, and the word return becomes almost decorative. It still exists in the sentence, but the substance has vanished. This is what another galaxy does to the human lifespan. It stretches it past recognition. Even if we imagine a future spacecraft vastly faster than anything we have now, the problem remains severe. Unless the ship reaches a meaningful fraction of the speed of light, the travel time remains not just long but civilization-breaking. And if it does reach such speeds, then other problems rise to meet it, as we will come to later. But for now, what matters is simpler. The journey is too large for a single life. That fact changes the emotional reality of the mission long before launch. Picture a person standing beneath a night sky, knowing they have been chosen for the most ambitious voyage in history. At first, it sounds glorious. But then the meaning arrives all at once. They will never come back to anything they know. Not their family. Not their language as it is now. Not their culture. Not the earth they remember. If they somehow survive the trip, then whatever they return to will not be their world in any living sense. And if they do not survive it, then they are not a traveler returning with knowledge. They are the beginning of a relay. That relay idea leads naturally to one of the oldest proposed answers to long-distance space travel, the generational ship. The concept is simple enough to understand. If no one person can survive the full journey, perhaps a ship can be built as a small, self-contained world. People live on it, grow old on it, die on it, and their descendants continue onward. The destination is reached not by the original crew, but by the far future population of the ship. At first glance, this sounds like a solution. But look closer, and it feels less like a journey and more like an exile that reproduces itself. A generation ship is not simply transportation. It is a floating civilization. It must carry not just bodies, but a way of life. Food systems, water systems, medicine, education, governance, psychological stability, conflict resolution, reproduction, repair, cultural continuity, meaning. And all of it must survive not for months or years, but for generations without relief. This is where the problem becomes profoundly human. Because machines can, in theory, be maintained. Systems can be designed. Redundancies can be built. But the passengers are not engine parts. They are people. They fall in love, grow bitter, feel trapped, rebel, dream, grieve, become curious, become tired, form loyalties, break rules, change values, reinterpret old stories, and ask the most dangerous question of all. Why are we still doing this? That question is not a side issue. It is central. The original mission might be written with great seriousness, a noble purpose, a destination of almost sacred importance. But what obligation does the 10th generation feel toward a goal chosen by ancestors long dead? What if the destination means less to them than the ship itself? What if ship life becomes normal life? What if the voyage stops feeling like a journey and starts feeling like a prison decorated with mythology? This is one of the deepest weaknesses of the generation ship idea. It assumes that purpose can remain stable across time. But human purpose is not perfectly stable even across a single lifetime. How much less across centuries? And there is another problem hidden inside it. The children born on such a ship did not choose the mission. They inherited. Their entire world would be artificial walls, controlled systems, and stories about a home they never saw and a destination they did not select. Perhaps some would embrace that inheritance. Perhaps many would. Human beings are adaptable. But adaptation is not the same thing as consent. In that sense, a generation ship begins to feel morally complicated. You are not simply sending explorers. You are creating descendants whose lives are spent inside the consequence of a decision they never made. That may still happen someday for shorter interstellar missions, depending on what kind of civilization humanity becomes. But it reveals something important for our larger question. Once a trip exceeds the span of one life, it stops being a straightforward act of travel. It becomes a social and ethical project of extraordinary weight. And this is still only about getting there. Coming back is even harder to imagine. Because a return journey would demand another multi-generational commitment, another inheritance chain, another long suspension of ordinary human meaning. Even if the outbound mission succeeded, even if a stable society formed aboard the ship, even if the destination were somehow reached and survived, why would anyone choose to reverse the entire burden? Return to what? To descendants of descendants of descendants on an Earth that has changed beyond recognition? The word home, at that point, becomes a story older than memory. If this slow journey through the deeper human side of cosmic distance is helping you unwind, you can leave a like, subscribe, or simply stay here in the quiet. And if you feel like leaving a comment, I'd love to know which seems harder to imagine, living your whole life on a generation ship, or being the first person to step onto it. Because the lifespan problem is not only about death. It is about identity across time. It is about whether a mission can still be called one mission when the people carrying it forward are no longer the people who began it. And perhaps the most haunting part is that even if we set aside generation ships, the alternatives are not simple. People often reach for suspended animation here. Cryosleep. Hibernation. Some kind of long, artificial sleep that preserves the body while time passes outside. It is a beautiful idea, and a very old one in science fiction. Go to sleep under one sky and wake up under another, skipping the terrible middle. You can understand the appeal immediately. It protects continuity. The same person leaves and arrives. At least in principle. The long delay still happens, but subjectively the traveler avoids most of it. The centuries or millennia become a single missing chapter instead of an entire lived burden. But even if we imagine such technology someday becoming possible, it does not fully solve the deeper emotional truth. It only changes how the traveler experiences the passing time. It does not stop the outside world from moving on. It does not preserve Earth as it was. It does not hold still the people you loved. It does not keep your culture waiting patiently in the dark for your return. If you sleep for 10,000 years and wake up at your destination, the gap has still happened. You have only stepped over it internally. Everyone else was carried by it. And if the trip lasts longer than even civilization itself, then waking at the destination does not feel like arriving at the end of a difficult voyage. It feels more like being thrown forward into a future where your entire origin has become archaeology. That is why the one-way character remains. Because even when you protect the body, you cannot protect the bond between traveler and home. Then there is life extension, another dream that often appears in these conversations. What if humans lived for hundreds of years? Or thousands? Would that solve the problem? It would certainly change it. A longer life would make longer journeys more imaginable. But again, scale is cruel. Another galaxy does not require a somewhat longer life. It requires duration so extreme that even radical longevity begins to look small. Extending a life from 80 years to 500 is astonishing by human standards. But against cosmic travel, it may still feel like a candle offered to a winter night. This is the recurring pattern. Every solution that sounds dramatic on Earth begins to shrink when placed beside galactic distance. Longer lives help, but not enough. Sleeping helps, but not enough. Passing the mission to descendants helps, but not enough. The problem is not that these ideas are foolish. It is that the universe is larger than the scale they were designed to overcome. And beneath all of this lies a quieter truth that may matter most of all. Human beings do not merely want to survive a journey. We want the journey to mean something in our own lived frame. We want departure and arrival to belong to one life, or at least to one emotionally coherent story. That desire is not childish. It is deeply human. We do not dream of reaching another galaxy as a purely technical transfer of matter. We dream of seeing it, of remembering Earth while standing beneath alien stars, of comparing one sky with another, of carrying one world inside us while discovering the next. The dream is personal. But once the journey exceeds the lifespan that holds a personal story together, the dream begins to detach from its original emotional form. The mission may remain possible in some cold future sense, but the dream changes. It is no longer, "I will go." It becomes, "Someone, someday, may continue what I began." That is a very different sentence. And it is not wrong. There is dignity in planting a flag for a future you will never see. Humanity has always built some things for descendants. Cathedrals, laws, libraries, orchards. Great projects often outlive their makers. But even those projects still unfold within the continuity of place. They remain connected to home. Intergalactic travel tears even that connection loose. You are not just building for descendants. You are sending descendants away from the very frame that made the project meaningful. That is why another galaxy begins to feel like a one-way journey long before we discuss hard relativity. The lifespan alone is enough to bend the emotional meaning of the trip beyond repair. And perhaps that is why the night sky can feel so beautiful and so melancholy at the same time. Every galaxy we see is real. Every distant spiral is a place, in the broadest physical sense. But being a place is not the same as being reachable within the arc of a human life. Some lights in the sky do not function as destinations for beings like us. They function as reminders of scale, of time, of the strange fact that the universe contains more than life can personally hold. There is a kind of peace in admitting that, not resignation, not defeat, just clarity. We are brief, yes, but within that brevity we have done astonishing things. We have learned to measure galaxies we cannot touch. We have understood the age of stars we will never visit. We have taken the small window of a human lifetime and used it to look millions and billions of years outward. That is its own kind of greatness. Maybe the lifespan problem is painful only if we imagine human value depends on physically reaching every wonder we can see. But perhaps it does not. Perhaps part of maturity, scientific and emotional, is learning that understanding and possession are not the same thing. You can deeply know a thing without owning it. You can love a horizon you will never stand upon. You can let a galaxy remain distant and still feel changed by it. Still, if we speak honestly about travel, then honesty forces the harder conclusion. A person cannot casually visit another galaxy in the way we naturally mean visit. Not because the desire is weak, not because imagination has failed, but because a human life is too small a container for the whole journey. And once that becomes true, the structure collapses. The trip becomes a relay, or a sleep through history, or a drift into a future severed from the world you left. Every version preserves the outward motion, None preserve the old human meaning of return. So the problem of lifespan is not a side note in the story of intergalactic travel. It is one of the central reasons the journey becomes one way. The body is too brief. The memory is too fragile. Home changes too much while you are gone. And by the time you could ever hope to come back, if such a thing were somehow possible, the world that taught you what home meant would no longer be there to receive you. That is the quiet heartbreak beneath the numbers. Not just that another galaxy is unimaginably far, but that the life doing the imagining is unimaginably short beside it. And that truth changes everything. Part 6. The empty space between galaxies. When most people imagine a journey to another galaxy, they picture the destination first. They imagine the spiral shape of Andromeda hanging in the dark. They imagine strange new stars, alien skies, perhaps worlds circling suns that no human eye has ever seen up close. The mind naturally leaps ahead to arrival. It fixes on the beauty at the far end of the trip. But between here and there is something far more important. Not a planet, not a star, not a hidden station in the dark, just space. And not the familiar kind of space we casually imagine when we think about the solar system, where there are still planets, moons, comets, asteroids, sunlight, and the quiet sense that home is still somewhere nearby. The space between galaxies is something else. It is not simply farther out space. It is a different emotional and physical environment altogether. It is emptiness on a scale that changes the meaning of the word. And that emptiness is one of the deepest reasons a trip to another galaxy feels less like a voyage and more like a one-way surrender to the void. Because once you leave the Milky Way behind, you are no longer crossing a region filled with familiar structure. You are no longer traveling through a stellar city. You are moving into the vast dark between cities, where the lights are so few and so far apart that direction itself begins to feel lonely. This is one of the hardest parts of the story to truly absorb. We know, in a general way, that space is empty. We say it easily, almost casually. But most of us do not really stop to ask what kind of emptiness that means. On Earth, emptiness is never complete. A desert may seem empty, but it still has wind, sand, heat, cold, a horizon, a sky, and a living planet beneath it. The middle of the ocean may feel isolated, but there is still water in every direction, weather above, life below, and a world holding you in place. Even Antarctica, for all its vast silence, still belongs to Earth. It is still wrapped inside a biosphere, still under a sky shaped by air and light and weather. The emptiness between galaxies is not like that. It is not a remote region of a living world. It is not a difficult extension of home. It is the absence between homes. And that absence is so great that it almost becomes its own kind of presence. Inside the Milky Way, even though stars are very far apart, there is still a sense of belonging to something structured. There are billions of stars, clouds of gas, dark nebulae, star-forming regions, ancient clusters, stellar remnants, faint dwarf stars, dense central regions, spiral arms full of history and motion. A spacecraft traveling within the galaxy would still, in some sense, remain inside a luminous civilization of matter. But once you head outward, beyond the visible body of the galaxy, something changes. The stars begin to thin. The great river of the Milky Way fades behind you. What had once felt like a universe full of lights starts to reveal itself as an island. And that island begins to shrink. This is one of the strangest things about perspective in the cosmos. From Earth, our galaxy feels immense. It arches across the night as a pale band of countless distant suns. It seems almost endless. Yet if you could somehow travel far enough away, the whole Milky Way would gradually become what other galaxies already are to us now. A bright shape suspended in darkness, beautiful but remote, bounded by the emptiness around it. And that emptiness is where the true intergalactic journey lives. It is easy to assume that because there is some gas between galaxies, and because the universe is never perfectly empty, the term void might be exaggerated. But this misses the point. The space between galaxies does contain matter, yes, but so little of it that for any human intuition it might as well be almost nothing at all. In some intergalactic regions, there may be only a few atoms in a cubic meter, sometimes fewer. Imagine a volume of space the size of a room around you, and inside that room there may be almost nothing. No air, of course. No dust clouds thick enough to see. No nearby sun warming the darkness. No landscape. No steady flow of recognizable matter. Just sparse particles, scattered so thinly that the emptiness feels almost absolute. That is not poetic exaggeration. That is one of the real physical qualities of the void. And this is important because empty space is not merely space without scenery. It is space without support. No fuel depots. No planetary shelters. No natural places to pause. No obvious landmarks that mean safety. The trip from one galaxy to another is not like sailing from one coast to another across a difficult ocean. It is more like launching yourself away from all coasts at once and hoping the direction itself remains meaningful long enough to endure. There is something quietly terrifying in that, though perhaps terrifying is too sharp a word for this channel. Maybe a better word is final. Because the emptiness between galaxies feels final in a way other distances do not. Inside the solar system, even the most distant probe still belongs to a known family of objects. There is still the sun, still the architecture of planets and orbits, still a sense that one can point to where things are and name them with some emotional familiarity. Even within the wider Milky Way, however distant the stars may be, there is still the galaxy itself as a kind of environment. A grand one, yes, but an environment nonetheless. Intergalactic space strips that feeling away. There is no nearby local scenery to belong to. Only the faint receding memory of one galaxy behind you and the almost unreachable promise of another ahead. This is why the word journey starts to change here. A journey usually implies not just motion but passage through places, through changing scenes, through a sequence of environments that mark the movement of time. Roads bend, landscapes shift, cities appear, horizons open and close. Even long flights across Earth still contain a relationship to geography. But what is the middle of the trip to another galaxy? What does the traveler see after the first year, or the 100th, or the 10,000th? Mostly the same dark. Mostly the same thin scattering of distant light. Mostly the same knowledge that nothing nearby can help, witness, or interrupt the motion. There is a psychological consequence to this kind of emptiness that is easy to overlook when speaking only in equations. Human beings do not merely travel through distance. We travel through context. Context tells us where we are in the story. A forest becomes a mountain path, then a valley, then a village. A flight becomes takeoff, cloud, descent, arrival. Even a ship at sea has sunrise, weather, waves, constellations that slowly shift, signs of coastlines and currents, clues that the world is changing around you. The void between galaxies offers very little of that. If one could endure it at all, the journey would become an experience of prolonged sameness unlike anything in ordinary human life. Not because nothing exists, but because so little changes at a humanly meaningful scale. The stars would drift only gradually. The destination would remain stubbornly distant. The departure point would slowly dim into a memory. Time would continue, but without the comforting rhythm of environments. And in that strange sameness, the emptiness itself becomes part of the burden. People sometimes imagine the danger of deep space in active terms. Explosions, system failures, collisions. Those matter, and we will come to some of them. But there is also a quieter burden, the psychological weight of uninterrupted absence. The knowledge that there is no nearby world, no accidental refuge, no natural stop between galaxies. Only the long suspension of being between meaningful places. If this calm exploration of the deep cosmos is helping you unwind, you can leave a like, subscribe to the channel, or simply stay here with the silence of it. And if you feel like sharing a thought, I'd love to know what feels more unsettling to you, the size of another galaxy, or the emptiness between ours and it. Because in many ways, it is the space between that does the real work of making the journey one way. A galaxy, after all, is at least a destination. It is full of stars, structure, gravity, and possibility. The void offers none of that. It is not a place you wish to linger. It is only what you must surrender yourself to for longer than the human mind naturally knows how to measure. There is also an important scientific truth hidden in this emptiness. Galaxies are not evenly sprinkled through space like dust in a beam of sunlight. They gather in clusters, groups, filaments, and large-scale structures, with enormous regions between them where matter is especially sparse. The universe, on its largest scales, resembles a kind of cosmic web. Galaxies trace out threads and knots, while vast dark gaps stretch between these brighter structures. That means the universe is not just big, it is unevenly big. There are places where matter is more concentrated, where galaxies gather under gravity into rich communities. And there are places where the emptiness deepens, where the distance between meaningful structures becomes almost absurd. Even our own local group, which includes the Milky Way and Andromeda, is still part of a much larger architecture of clustering and separation. So when we imagine traveling from one galaxy to another, we are not just imagining a straight line between two bright objects. We are imagining motion through a universe whose very large-scale structure is defined as much by absence as by presence. That is a difficult thing for the mind to hold, because we are naturally drawn to the objects themselves. The stars, the galaxies, the nebulae. We make calendars and wallpapers and telescope images out of the luminous things. But cosmically speaking, much of reality is the dark interval between the luminous things. And that interval is not empty only in a scientific sense. It is empty in a narrative sense too. Nothing much happens there that feels like progress. The middle of an Earth journey can be meaningful. You cross a forest. You pass another town. You meet weather. You follow currents. But in intergalactic space, the middle is almost too middle. Too long. Too unchanged. Too lacking in chapters. A traveler could spend immense stretches of time not arriving, not departing, not discovering anything new in the usual sense, but simply remaining in transit. That is a very strange condition for a human story. It stretches purpose thin. It makes motivation harder to carry. It turns even hope into something that must survive without immediate reinforcement. And perhaps that is why the void feels so final. Not because it is evil or dramatic, but because it offers so little in return for the passage through it. No companionship. No scenery worth naming at close range. No ordinary milestones. Only the persistence of the mission and the slow movement of time. There is another layer here as well, one that becomes more poignant the longer you think about it. Light itself travels through this emptiness. The glow from Andromeda crosses the intergalactic dark for millions of years before reaching us. Photons leave its stars and drift through the void with extraordinary patience. No road. No atmosphere. No guide. Just motion across almost perfect darkness until, by extraordinary chance, a few of them reach Earth and fall into human eyes. That means whenever you look at another galaxy, you are already receiving something that has successfully made the crossing. Not a ship. Not a person. Not a message crafted by intelligence. Just light. And light is the only reason these distant galaxies feel close enough to imagine. But there is a hidden sadness in that too. Light can cross the void because it asks almost nothing of the universe. It does not need air, food, shielding, rest, or memory. It does not age in the way we do. It does not lose heart halfway there. It does not wonder whether the destination is still worth reaching. A human traveler would carry all those burdens. That is the true difference between seeing another galaxy and going to one. Looking is easy for the universe. Going is not. And the emptiness between galaxies is where that difference becomes most honest. Because if there were many worlds in the middle, many natural outposts, many stepping stones between one spiral island and another, then the journey might at least be imaginable as a sequence of survivable pieces. Still difficult, but broken into chapters. A route. A progression. But there are no such natural chapters waiting for us in the intergalactic dark. There is no chain of welcoming stars laid out across the void. No cosmic bridge of habitable worlds. No obvious infrastructure written into the universe itself. The traveler must bring almost everything with them, and bring it for the entire crossing. That changes the emotional meaning of departure. Leaving for another galaxy is not like setting out and trusting that the road will provide. It is more like cutting the last thread behind you and accepting that there may be no meaningful support until the destination itself. And even then, the destination may not resemble the image that called you toward it. Because so much time passes in these crossings that what lies ahead is never quite the same thing you first imagined. The galaxy you set out for continues to evolve while you are on the way. Stars are born. Stars die. Orbits shift. Structures change. Nothing holds still to make the trip easier for your sense of continuity. This means the void does something subtle but profound. It erodes not just the practical possibility of return, but the emotional symmetry of the whole journey. You do not simply go from one stable place to another stable place. You leave one changing world, cross an immense absence, and arrive at another changing world after so much time has passed that the original dream no longer fits cleanly over the reality. That too is part of the one-way nature. The emptiness does not only separate places. It separates versions of reality. In the middle of the void, the old life behind you becomes increasingly unreachable not just in space, but in meaning. And the life ahead becomes increasingly abstract, because it remains only a distant promise for longer than an ordinary human psyche naturally knows how to hold a promise. This is why intergalactic space feels almost philosophical when you sit with it long enough. It is not just a physical region. It is a lesson in what happens when absence becomes the dominant feature of a journey. On Earth, we are used to abundance of cues. Sound, weather, people, roads, buildings, language, changing light. Even solitude on Earth is still framed by countless signs that a world surrounds you. The void between galaxies offers almost none of those signs. Only dark. Only distance. Only the long, thin thread of motion. And yet there is something beautiful in that too, if we let it be beautiful in the right way. Not beautiful because it invites conquest. Not beautiful because it promises easy discovery. But beautiful because it reveals the universe honestly. The galaxies are not crowded neighbors in a friendly town square. They are luminous islands suspended in an ocean of almost unimaginable emptiness. They shine all the more beautifully because the darkness between them is real. Their light means more because it has crossed so much absence to reach us. Maybe that is part of what makes the night sky emotionally powerful even for people who know little astronomy. Some deep part of the mind senses the contrast. The light is lovely, yes, but the darkness carrying it is just as important. Without the emptiness, the stars would not feel so haunting. And perhaps there is a quiet human lesson hidden there as well. We often think the universe is made mostly of things. Suns, planets, galaxies. But in another sense, it is also made of intervals, distances, silences, waiting, vast pauses between the bright events. Reality is not only substance, it is spacing. And nowhere is that truer than between galaxies. So when we ask why visiting another galaxy is a one-way journey, part of the answer lives here in the void itself. The space between galaxies is not an ordinary route. It is not a hard road with sparse towns. It is a nearly total absence of natural support stretched across a timescale that dissolves familiar human meaning. Once you enter it, you are no longer moving through a world arranged for return. You are moving through the longest kind of between home and a future you may never fully share, between one island of light and another, between the life that launched the journey and the reality that waits at the far end. And that between is so large, so dark, and so indifferent that by the time you have truly crossed it, the word return has almost no old meaning left. Because the void is not just empty space. It is the great eraser of continuity. And that is what makes the journey feel one way long before you ever arrive. Part 7. The Hidden Dangers Waiting in the Dark. If the distance between galaxies were the only problem, the story would already be difficult enough. If the emptiness of the void were the only burden, that alone would be enough to turn the dream into something much heavier than it first appears. But the universe is not content with distance and emptiness alone. It adds danger. Not always the dramatic kind we are used to in films. Not constant explosions, flashing alarms, or sudden monsters in the dark. The real dangers of such a journey are quieter than that, and in some ways, far more unsettling. They are the kinds of dangers that do not announce themselves with spectacle. They accumulate. They wait. They wear things down. They turn time itself into an enemy. And that matters, because a trip to another galaxy is not simply long. It is long enough for small threats to become immense. That is one of the strangest truths about extreme travel. On a short mission, many problems remain manageable. A little radiation exposure, a small systems glitch, a period of loneliness, a maintenance issue, a delay in repair. These are serious, but they can be survived if the journey is brief enough and help is near enough. But once a journey stretches across years, decades, centuries, or more, the character of danger changes. What was once a manageable difficulty becomes a slow form of destruction. The hidden dangers of intergalactic travel are like that. They do not merely threaten to end a mission suddenly. They threaten to erode it gradually, patiently, almost invisibly, until there is nothing left of the original plan but a machine or a crew trying to survive the consequences. That is why this part of the story matters so much. Because even if, somehow, we solved the distance problem better than we can now imagine, even if we built engines beyond anything humanity has yet achieved, the journey would still have to pass through a region of space that is deeply hostile to life. Not hostile in a personal sense, of course. The universe does not hate us. It simply does not protect us. And once you leave the shelter of Earth, that truth becomes unavoidable. Here on our planet, we are wrapped in layers of quiet defense so constant that we rarely stop to notice them. We have an atmosphere that softens incoming radiation and burns up many small intruders from space. We have a magnetic field that helps deflect charged particles streaming from the sun. We have oceans, rock, air pressure, biological cycles, and an entire planetary system evolved to sustain living things like us. Space offers almost none of that. The moment you leave Earth, you begin leaving behind a world that has spent billions of years solving survival problems on your behalf. That is what a planet really is for creatures like us. Not just land beneath our feet, but a vast protective system so successful that we mistake it for normality. In deep space, normality disappears. And one of the first dangers waiting there is radiation. Radiation is easy to mention and hard to emotionally grasp, because it is invisible. You cannot see it gathering. You cannot watch it approach like a storm front. It does not always give immediate warning. And perhaps for that reason, it feels abstract to many people. But for a long voyage through intergalactic space, radiation would not be abstract at all. It would be one of the most persistent and serious threats to both human bodies and the machines keeping those bodies alive. There are different kinds of radiation in space, but the broad picture is simple enough. The cosmos is full of energetic particles. Some come from the sun. Some come from violent events elsewhere in the galaxy or beyond it. Some belong to what we call cosmic rays, fast-moving charged particles carrying enough energy to damage cells, disrupt electronics, and slowly wear away at the safety of anything traveling without the protection of a planet. On a short mission, radiation is already a major concern. Astronauts aboard the International Space Station receive more radiation than people on Earth. Missions beyond low Earth orbit, such as journeys to the Moon or Mars, must take this even more seriously. The farther you go from Earth's protective envelope, the more exposed you become. Now stretch that exposure not across weeks or months, but across enormous spans of time. The danger stops being something you manage around the edges. It becomes one of the defining facts of the journey. For the human body, chronic radiation exposure is not a small inconvenience. It increases cancer risk, damages DNA, harms tissues, affects the nervous system, threatens fertility, and raises the possibility of long-term deterioration in ways that are still being studied even for much shorter missions than anything interstellar or intergalactic would require. A body can endure many things, but it is not designed for prolonged unshielded passage through deep cosmic radiation. Shielding sounds like the obvious answer, and in one sense, it is. You protect the crew behind mass. Water, specialized materials, thick walls, perhaps future technologies we do not yet possess. But shielding creates its own burden. Protection means weight. Weight means more mass. More mass means more propulsion challenge. And so, once again, the physics loops back on itself. Every attempt to solve one deep space problem tends to make another problem heavier. This is one of the great patterns of long-range space travel. Solutions are rarely free. Every form of safety must be carried, powered, maintained, and justified against the terrible arithmetic of motion. And radiation does not threaten only the people aboard. It threatens the ship. Electronics exposed to deep radiation for long periods can degrade, suffer bit errors, malfunction, or fail outright. Tiny disruptions that might be tolerable for a probe on a short mission become more serious when the machine in question is part of a self-contained habitat carrying lives that depend on constant reliability. A spacecraft crossing the void would not merely need to endure radiation. It would need systems designed to keep functioning despite it, perhaps for spans longer than most things humans have ever built were meant to survive. That alone is difficult enough to feel almost unreal. But radiation is only one danger. Another is impact. This surprises some people, because space is mostly empty, and that is true. But mostly empty does not mean perfectly empty, and at high speeds, even very small things become dangerous in ways that are difficult to overstate. On Earth, a grain of sand is almost nothing. A speck, a detail, something brushed aside without thought. In deep space, at sufficiently high velocity, even a tiny particle can hit with enormous energy. The danger is not because the particle is large. It is because speed transforms small mass into violence. A ship moving through intergalactic space at a meaningful fraction of light speed would not be gliding gently through a harmless vacuum. It would be cutting through a medium sparse enough to seem like nothing, but not empty enough to guarantee peace. Dust grains, stray particles, microscopic debris, all the little things that do not matter at ordinary speed begin to matter a great deal when relative velocity becomes extreme. A tiny impact at those speeds could damage shielding, penetrate layers, disrupt instruments, or, in the worst cases, trigger failures that spread beyond the point of contact. One speck might not destroy a well-designed ship, but over immense time, the ship would not face one speck. It would face the cumulative risk of exposure over distances so great that even improbable events begin to acquire patience. This is another way long journeys turn the universe against us without ever needing drama. Time multiplies risk. What is unlikely on a short path becomes more meaningful on a very long one. And unlike on Earth, where damage may be repaired with outside help, resupply, and infrastructure, a ship in intergalactic space would have none of that. No dry dock, no emergency port, No easy replacement parts waiting just over the horizon. Whatever broke would have to be fixed by what the ship already carried, or else endured. That leads naturally to another hidden danger, one that may be even more serious than radiation or dust. Failure. Not one grand catastrophic failure, though that is always possible. Something quieter than that. The slow accumulation of wear in closed systems. A long-range ship is not just a vehicle. It is an artificial ecosystem. It must provide air, water, temperature control, waste recycling, food production or storage, medical care, structural integrity, software stability, and power generation. Every one of those systems contains components. Every component ages. Every material experiences fatigue. Every design, no matter how elegant, contains assumptions about maintenance and lifespan. And that is on Earth, where engineers can inspect, replace, upgrade, and repair within a living civilization. A ship alone between galaxies cannot rely on that comfort. It must survive by carrying its own future within it. That means spare parts, repair tools, manufacturing capability, diagnostic intelligence, redundancy layered upon redundancy, and perhaps even systems capable of reconfiguring themselves when original configurations fail. A spacecraft like that begins to look less like a machine in the ordinary sense and more like a mobile world of maintenance. Its true cargo is not merely people or instruments. Its true cargo is continuity. And continuity is incredibly hard to preserve over long durations. Think about the most reliable object you own. A watch, perhaps. A car that served for years. A piece of software that somehow kept working. Even the most dependable things eventually wear, glitch, or become incompatible with changing conditions. Now imagine asking a closed mechanical and biological system to preserve life not for years, but for spans so long that entire civilizations on Earth might rise and fall while it remains in transit. The mind almost resists the picture. A single pump failure, a single seal degrading, a crack growing very slowly under stress, a software corruption going unnoticed, a microbial imbalance in a life support loop, a crop failure in a controlled ecosystem, a contamination event in the water system, a medical emergency that cannot be referred to any hospital outside the hull. Each problem by itself might sound manageable. But long-duration survival is not defeated only by spectacular disaster. It is defeated by the inability to guarantee that nothing crucial ever goes wrong in a way the ship cannot repair. That is the true fragility of isolated systems. They do not get to choose which failure arrives. And the longer the journey, the more time failure has to search. Then there is the problem of life support itself, one of the least glamorous and most decisive challenges of all. Life on Earth feels effortless because Earth is doing almost everything for us all the time. We breathe because the atmosphere already exists. We drink because the planet cycles water through rain, rivers, aquifers, and oceans. Plants grow in vast ecological networks. Heat and cold vary, but within a range life has learned to inhabit. Waste is absorbed by natural systems far older and larger than us. A spacecraft must imitate pieces of all that with finite resources inside metal walls. And imitation is not the same as abundance. If the journey is short, this is a hard engineering problem. If the journey is very long, it becomes a test of whether a human-made environment can remain stable under conditions it was never naturally evolved to survive. Air must be recycled or generated without fail. Carbon dioxide must be scrubbed. Oxygen levels must remain stable. Water must be purified again and again. If food is grown aboard, then light, nutrients, disease control, pollination are substitutes, and ecological balance all become essential. If food is stored, then storage duration becomes part of the mission's realism. Nothing about this is trivial. A ship crossing intergalactic space would have to become a miniature Earth, but without Earth's depth, scale, resilience, and forgiving complexity. And that is perhaps the most humbling comparison of all. We often talk as if a sufficiently advanced spacecraft could simply support life, but life is not one process. It is many overlapping systems working together under conditions of extraordinary balance. Human beings are not batteries you keep charged. We are biological events held together by countless subtle requirements. The longer you travel, the more those requirements matter. Then, quietly, another danger enters the picture. Isolation. Of all the hazards of deep space, this is one of the easiest to underestimate, because it sounds soft compared to radiation or impact. It sounds emotional rather than physical. But the human mind is not separate from the body. It is part of survival. If the mind begins to fracture under extreme isolation, every technical system becomes harder to manage, every relationship more fragile, every judgment less reliable. Even relatively short periods of confinement can strain people in powerful ways. On Earth, researchers in remote stations, submarines, polar regions, and long-duration simulations have already seen the effects of monotony, separation, limited privacy, disrupted rhythms, interpersonal tension, and psychological fatigue. And those environments, difficult as they are, still exist within reach of Earth. There is still a planet outside. There is still a rescue possibility, at least in principle. There is still weather, gravity, and the deep knowledge that one belongs to a living world. Intergalactic isolation would be unlike any of that. No real-time conversation with home. No possibility of rescue. No horizon outside the ship that promises land, air, or a change of scenery. Just the same artificial interior, the same crew, the same routines, the same knowledge that there is nowhere else to go. That kind of confinement does not only challenge patience, it challenges identity. People need variation. They need meaning. They need contact with more than surfaces and schedules. They need ways to measure time that are more alive than counting tasks. On a long enough shipboard life, monotony itself becomes a hazard. Not dramatic enough to inspire movies, perhaps, but real enough to erode morale, attention, and purpose. And purpose matters more than people sometimes think. A crew can survive hardship more easily if hardship has a clear shape and a visible endpoint. Humans endure difficulty well when the story of endurance still feels meaningful. But what happens when the endpoint is generations away? Or when the destination is too far to feel emotionally real, or when everyday life shrinks into maintenance of systems that exist only so maintenance can continue? At that point, the threat is not just loneliness. It is existential fatigue. The danger that people will continue functioning outwardly while inwardly losing the thread that makes the mission worth carrying. If this calm descent into the realities of deep space is helping you relax, you can leave a like, subscribe to the channel, or just stay with the quiet of the story. And if you want to share a thought below, I'd be curious what seems like the hardest danger to live with: radiation, mechanical failure, or the silence of knowing no one can come for you. Because all of these dangers have one thing in common: distance amplifies them. Radiation becomes more dangerous because exposure lasts longer. Mechanical wear becomes more dangerous because repair opportunities are finite. Isolation becomes more dangerous because the mind has more time to circle itself. Even tiny risks become more serious because the voyage is long enough for probability to gather patience. That is the hidden brutality of an intergalactic mission. The ship does not need to survive one challenge once. It needs to survive a whole ecology of threats continuously, without relief, while remaining meaningful to the people inside it. And even then, the story is not finished. There is always the possibility of the unknown. This does not mean monsters or supernatural forces. Nothing so theatrical. It means the ordinary humility of admitting that a journey through environments we have never truly inhabited may reveal problems we have not fully anticipated. Biology behaves strangely in altered conditions. Materials behave differently under long-term stress. Social systems drift. Minor design flaws become major after enough time. The unknown is not exotic. It is simply what remains when no one has ever lived through the full mission before. This is how difficult frontiers really work. Not just by challenging what we know, but by exposing the edges of what we forgot to ask. And that is one more reason a trip to another galaxy becomes one way. Because the farther you go, the less recoverable your mistakes become. On Earth, failure can often be met by outside structure. A hospital, a factory, a city, a larger system holding the broken piece. But a ship in the void has no larger system waiting to absorb its failures. It is the whole world for those aboard. That is an almost unbearable responsibility for any machine. And yet there is a strange kind of beauty in seeing this clearly. Not because danger is beautiful in itself, but because truth has its own quiet dignity. The universe is not small. Life is not simple. Survival is not guaranteed. And still, from within one brief species on one protected planet, we have learned enough to understand the shape of the challenge. We can see, even without solving it, how profound the problem really is. Maybe that matters. Maybe there is value not only in reaching the stars, but in honestly measuring what the reaching would cost. Because once the hidden dangers of the journey are placed beside the distances we have already discussed, the old fantasy begins to soften into something more mature. More sorrowful, perhaps, but also more truthful. Another galaxy is not merely far away. It is separated from us by a corridor of radiation, wear, vulnerability, and silence so unforgiving that a traveler must gamble not just on speed, but on the uninterrupted survival of every fragile thing keeping life together. That is a lot to ask of a ship. It may be too much. And if it is too much, then the one-way nature of the journey becomes even clearer. Not only because return takes too long, not only because home changes while you are gone, but because the act of remaining alive all the way across may already demand so much that to attempt the crossing at all is to accept a level of risk from which ordinary return no longer feels like the right framework. Perhaps that is the deepest hidden danger of all. Not radiation, not impact, not mechanical decay, but the quiet shift in meaning that occurs when survival itself becomes such a total project that the old idea of a trip disappears. At that point, you are no longer visiting another galaxy. You are surrendering your life to the attempt. And that is why the dark between galaxies does not feel like a road. It feels like a test no human story was originally built to pass. Part 8, Why Coming Back Would Be Even Worse. There is something comforting in the word return. It softens even the hardest journey. It suggests that no matter how far you go, the story still has a way back. A circle instead of a line. A departure that remains tied to home. That quiet promise lives inside almost every journey we naturally understand. You leave, you endure, you arrive, and then, if all goes well, you come back carrying memory like a lantern. The road may be long, but return gives it shape. That is why the idea of another galaxy feels emotionally possible at first. Not because the numbers are friendly. Not because the physics is easy. But because the imagination quietly assumes the old human pattern still applies. It imagines a ship leaving the Milky Way, crossing the dark, entering another galaxy, seeing wonders no one has seen before, and one day turning around to tell the story. But that final step, the turning around, is where the dream becomes something else. Because as hard as it is to reach another galaxy at all, coming back would be worse in almost every way that matters. Not a little worse. Not simply the same problem repeated twice. Worse in the practical sense, worse in the emotional sense, worse in the physical sense, and worse in the deepest sense of meaning. By the time you have crossed that distance even once, the old idea of return has already begun to dissolve. And if you somehow tried to force it back into existence, the journey would ask even more from you than it asked the first time. That is the hidden cruelty of intergalactic travel. The outward trip is not the whole cost. In some ways, it is only the beginning of the cost. To understand that, it helps to think about what arrival really means. Most people imagine arrival as relief, the end of strain, the closing of distance, the point at which the traveler can finally stop surviving and begin experiencing. But a journey to another galaxy would not work like that. Reaching the destination would not erase the problem. It would merely move the problem to a new location. Because a galaxy is not a platform waiting for you with fuel, repairs, medical care, and a familiar environment. It is another vast system of stars, dust, gravity, radiation, and unknown conditions. You would not arrive at a clean stopping point. You would arrive at a new scale of uncertainty. And before any return could even be imagined, there is a difficult truth you would have to face. You do not simply get somewhere in space. You must also stop there. That sounds obvious, but it changes everything. A spacecraft traveling at extraordinary speed is carrying enormous motion with it. If you spent years, decades, or longer accelerating toward another galaxy, then all of that velocity becomes a debt you owe at the far end. To make arrival meaningful, you must cancel enough of that speed to remain in the destination rather than slicing through it like a thrown stone skimming across water. Stopping is not free. It takes energy. It takes planning. It takes systems that still work after an almost unthinkable journey. And if the mission somehow included a return, then the same burden would appear again in reverse. Slow down to arrive, then speed up again to leave. Then slow down again to come home. 4 major acts of propulsion, not one. Accelerate outward. Decelerate into arrival. Accelerate for the return. Decelerate at home. Each one costs mass, energy, time, and safety. Each one magnifies the engineering challenge. Each one demands that the ship remain not just functional, but profoundly reliable across a mission profile so extreme that even talking about it begins to feel more like philosophy than planning. This is one reason a round trip to another galaxy is not just twice as hard as a one-way journey. It becomes heavier than simple multiplication suggests. Because every stage must be supported by systems and reserves carried through all the others. The ship must survive the outbound crossing while still preserving enough capacity to perform everything the return requires. It must protect the crew not just long enough to get there, but long enough to remain coherent for the thought of going back. And that raises another difficult question. What would make you go back? That may sound strange. Surely home would. Surely the whole point of return is that home remains the anchor of meaning. But by the time you have crossed to another galaxy, the meaning of home has already been changed by time, distance, and isolation. Even before relativity enters the story, even before we talk about time dilation in the next part, ordinary travel time alone begins to work against the concept of return. The outward journey is already so long that the place you left behind is no longer waiting in the old sense. It is moving on without you. Aging without you, perhaps vanishing in forms you would no longer recognize. That matters, because return is not just a direction, it is a relationship. To return somewhere meaningfully, that somewhere must still belong to the same emotional world that produced your departure. It can change, of course. All homes change, but not so completely that the word itself becomes ceremonial. Not so completely that the person returning is less a traveler coming home than a ghost arriving after history has turned over. This is where intergalactic return begins to feel almost heartbreaking. Because the longer and harder the outbound trip becomes, the less likely it is that the return has any old human meaning left. Suppose, somehow, impossibly or almost impossibly, a crew reached another galaxy. Suppose they survived the radiation, the isolation, the wear of systems, the emotional burden of deep time, the countless slow dangers that accumulate in a ship far from rescue. Suppose they arrived not broken, but intact enough to choose. Then what? Do they gather samples, record observations, and begin preparing for another crossing of the void? Do they choose to spend the rest of their lives trying to reach a Milky Way that no longer contains the version of Earth they remember? Do they ask their children to inherit that intention, then their grandchildren, and theirs after them? Or do they finally accept what the distance has been saying all along, that the outward trip was not the first half of a round trip, but the entire decisive act? Because by then, the return route is not just difficult, it is emotionally discontinuous. The old circle is broken. And there is another practical cruelty here as well. The destination galaxy does not automatically solve your resource problem. Reaching another galaxy does not mean you have arrived at a friendly port full of useful supplies arranged for your exact ship design. You may not know where safe worlds are. You may not have easy access to materials. You may not be equipped to harvest, refine, manufacture, and relaunch under alien conditions after a journey that already strained everything you brought with you. This is one of the quiet illusions of science fiction. Arrival often looks tidy. A ship reaches a destination, lands or enters orbit, then somehow continues the story with clean continuity. But in reality, arriving after a journey like this would likely leave a craft aged, depleted, and dependent on whatever long-duration capability it carried from home. If return required fresh propellant, major repairs, ecological reset, or large-scale rebuilding, then the destination would have to become not just a place of exploration, but a place of industry, a place of recovery, a place of near-miraculous self-sufficiency. And if you could build all that, then another question quietly emerges. Why return at all? If you can establish enough survival and manufacturing capability in another galaxy to rebuild the mission for a return crossing, then you are no longer speaking about a simple expedition. You are speaking about transplanting civilization. At that point, the logic tilts away from return and towards settlement, however small or reluctant. Because the cost of going back begins to look less like the completion of a journey and more like the rejection of the only viable future you have left. That is one more reason intergalactic travel takes on the character of exile. The farther you go, the more return stops being the natural completion of the mission and starts becoming an extra act of almost irrational attachment to a past that may no longer exist in any living form. If this quiet walk through the harder side of cosmic travel is helping you settle in, you can leave a like, subscribe to the channel, or simply stay here with the thought of it. And if you feel like sharing something below, I'd love to know what feels sadder to you, never reaching another galaxy at all, or reaching it and realizing you can never truly come home. Because in many ways, that second thought is the heavier one. There is also a deeper asymmetry between departure and return that deserves attention. When you leave home, the act is powered by curiosity. Even fear can be absorbed into wonder. The unknown ahead has a kind of glow around it. But on a return trip, the unknown is different. It is no longer the mystery of what lies ahead. It is the uncertainty of what has been lost behind you. That changes the emotional texture of the mission completely. An outward journey can survive on hope. A return journey must survive on memory. And memory is much more fragile. A person can endure extraordinary hardship while moving towards something new. Human beings are very good at leaning into the future when the future feels meaningful. But how do you sustain the same resolve on a journey back toward a place that may no longer contain anyone who knew you, any language that sounds like yours, any culture that remembers why you left, any landscape unchanged enough to feel like the home carried in your mind? At some point, the return becomes not a homecoming, but an archaeological expedition toward your own origin. That is a very different emotional engine, and weaker, in some ways. Because hope grows from possibility. Nostalgia grows from loss. One can carry hope across dark distances more easily than one can carry loss without being hollowed by it. This matters because long missions are not only made of machinery. They are made of motive. They are carried by the reasons people keep agreeing to continue. When the outward trip is framed as discovery, the mission has a positive horizon. When the return is framed as recovery of something irretrievable, it risks becoming a ritual of grief. Imagine a crew or a later generation aboard a ship preparing to turn back toward the Milky Way. What exactly are they turning toward? A birthplace told in stories? A species that has changed? A solar system altered by time? An Earth perhaps still there physically, perhaps not hospitable in the same way, perhaps no longer central to whatever humanity has become. This is where the return journey starts to feel not only harder, but almost cruel. Because it asks the traveler to dedicate another enormous stretch of existence to chasing continuity after continuity has already been broken. And all of that is before we even consider the condition of the ship and crew after the first crossing. A round trip assumes resilience that borders on the impossible. Systems must not merely survive one passage through the void. They must survive long enough to be trusted with a second. The life support loop must remain stable. The structural integrity must remain strong. The shielding must remain effective. The social fabric of the crew or descendants must remain functional. The mission's purpose must remain believable. Medical care must remain possible. Manufacturing and repair capacity must remain intact. And all of this must happen under conditions in which even short-term survival is already difficult. The first crossing ages everything. Not just the people, but the mission itself. It ages the materials, the electronics, the ecological systems, the habits of the crew, the clarity of the original goal. By the time a ship has actually reached another galaxy, it is not fresh at the start of a second journey. It is old, deeply old. Even if still operational, it carries history inside every component. Return would not begin from a state of strength. It would begin from accumulated fatigue. That makes the second crossing more dangerous than the first in a very literal sense. The ship would know more, perhaps. The travelers would know more. But knowledge does not erase wear. And wear is relentless. There is something almost tragic about that. The very success of the outward mission creates the conditions that make return harder. Arrival is achieved at the price of depletion, and depletion follows the ship into every future choice. Then there is the matter of scale itself. A return trip is not merely the repetition of a known route. Cosmic structures move. Galaxies shift. Local conditions evolve. The Milky Way and Andromeda, for example, are not static decorations on a chart. They are moving toward one another over immense time. On the largest scales, the whole cosmic environment is dynamic. A traveler trying to return across millions of years is not re-entering the same map. They are traveling through a reality that has continued changing without them. That means even the idea of back becomes less stable than it first appears. Back to where? Back to when? Back to what version of the galaxy? A route home sounds clear on Earth because Earth remains the same world on the timescale of ordinary journeys. But when travel times become cosmic, location and time can no longer be separated so cleanly. To go back in space is not to go back in life. The origin has already moved on. In that sense, return is an illusion created by language. It sounds like restoration, but physically and historically it is only another forward motion into a different future. That may be the deepest reason coming back would be worse. It asks for everything the outward journey asked for, plus a lie. The lie that the circle can be closed. The lie that home will still exist in the right form at the end of the line. The lie that more distance can heal the wound created by the first distance. But distance does not heal that kind of wound. It deepens it. Every year spent crossing back is another year in which the old world recedes, another year in which the traveler's memory and the destination's reality move farther apart. And this brings us to a quiet but devastating conclusion. A one-way trip to another galaxy is at least honest. It admits what the physics, biology, and time already suggest. It does not pretend the old human structure of departure and return can survive unchanged at cosmic scales. It says, plainly, that to go that far is to accept a future elsewhere, whether in body, in descendants, or in the fading continuity of a mission that no longer belongs wholly to its origin. A round trip, by contrast, clings to a symmetry the universe does not really support. That is why it is worse. Not only because it doubles the burden, though it does. Not only because it multiplies the risks, though it does. But because it tries to preserve an emotional pattern that intergalactic distance has already shattered. The traveler who leaves for another galaxy does not remain the kind of traveler who can simply come back. The act of leaving changes the category of the story. It is no longer travel in the old sense. It becomes separation on a scale so large that even return cannot undo it. Perhaps that is difficult to hear because the word return means so much to us. It suggests forgiveness by time. It suggests that roads, however long, still belong to home in the end. It suggests that distance can be folded back into intimacy if one only endures enough. But galaxies are too large for that comfort. They do not merely stretch the road. They unmake it. And maybe there is a strange peace in admitting that. Not because impossibility is comforting, but because clarity can be. Once we stop forcing intergalactic travel into the shape of an ordinary journey, we begin to see it for what it really is. Not a voyage with a difficult homecoming, but a profound and nearly irreversible severing from the scale of human life as we know it. That does not make the stars less beautiful. If anything, it makes them more beautiful. Because now they are not just places to be conquered in imagination. They are truths to be respected, distances to be honored, realities large enough to refuse our usual stories and ask for a different kind of humility. So if one day humanity ever does cross into another galaxy, it may not do so as tourists, or even as explorers in the old romantic sense. It may do so as something closer to seeds cast into a new darkness, carrying memory forward rather than expecting to bring it back. And that is why coming back would be even worse. Because by the time you are far enough away for another galaxy to become real around you, return is no longer a path. It is only the name we give to a home that time has already taken from us. Part 9, Time, Relativity, and a Galaxy That Won't Wait. There is one final hope people often reach for when the scale of intergalactic travel starts to feel unbearable. It arrives almost like a whisper. What about time? Not more fuel. Not a stronger hull. Not a better life support system. Something stranger than that. Something that seems, at first glance, almost like a hidden mercy written into the laws of physics. Because by the time we have followed this journey through distance, lifespan, emptiness, danger, and the near impossibility of return, one thought naturally remains. If the universe is this vast, then maybe there is still some way for the traveler to escape the worst part of it. Maybe the journey does not have to feel as long to the people on board. Maybe, somehow, the ship can outrun not only distance, but time itself. And in a very narrow, very specific sense, that hope is not entirely wrong. This is where the story becomes even stranger, and somehow even sadder. Because relativity does offer something that sounds like a loophole. But it is not the loophole most people want. It does not restore the old human shape of a journey. It does not preserve home. It does not keep the world waiting for your return. Instead, it reveals something deeper. It reveals that the universe may let you survive the trip more easily than it lets you come back from what the trip has done to time. That is the cruel beauty of relativity. The faster you move through space, the more unusual time becomes. This idea, first made clear in Einstein's theory of special relativity, is one of the most famous and least emotionally understood ideas in physics. People often hear a summary of it and treat it almost like science fiction. Time slows down for fast-moving objects. Clocks behave differently. Travelers at enormous speeds experience time in a different way from the people who remain behind. It sounds surreal, but it is real. It has been measured. It belongs to the structure of the universe. And once we apply it to the problem of another galaxy, something very important changes. The trip may remain unimaginably long for the outside universe. But for the traveler, Under the right conditions, it may feel shorter. That sounds like good news. In fact, for a moment, it sounds like the best news we have heard all journey. If a ship could travel close enough to the speed of light, then the time experienced on board would shrink compared with the time passing back on Earth. A journey that takes millions of years in the wider universe might feel much shorter to those inside the moving ship. Decades, perhaps, in some extreme imagined case. A lifetime, rather than an impossible stretch beyond all biology. For the human body and the human mind, that feels like a miracle. The same person who leaves might actually remain alive long enough to arrive. This is the point where many people feel the dream reawaken. Maybe that solves it. Maybe this is how the story becomes possible after all. Maybe the traveler can cross the abyss, step into another galaxy, and keep the journey inside one life. But then the second half of the truth arrives. And it is this second half that turns relativity from a hope into one more reason the trip becomes one way. Because time may slow down for you. It does not slow down for home. That is the part that changes everything. To feel the emotional weight of this, it helps to step away from equations for a moment and think in simpler terms. Imagine two clocks. One stays on Earth. The other leaves aboard a ship moving at a speed so extreme that ordinary intuition cannot follow it. From the point of view of the traveler, the onboard clock ticks normally. Your heart still beats one moment after another. You still think thoughts, eat meals, sleep, wake, remember yesterday, anticipate tomorrow. Your life feels like your life. Nothing inside your own experience tells you that time has become broken. It is simply your time. But when your journey is compared with the clock that stayed behind, the difference begins to appear. Less time has passed for you than for the people who remained at home. You do not age through the full amount of time that the outside universe does. In that sense, relativity is astonishingly generous and utterly merciless. Because what it gives to your body, it takes from your connection to everything you left behind. Suppose, in some fantastically advanced future, a ship could travel toward another galaxy at a speed very close to light. Suppose the crew experienced only a few decades during the outbound crossing. They would step aboard as adults and step out, perhaps old but still alive, into another galaxy. From their point of view, they survived. But outside the ship, millions of years may have passed. Earth did not travel alongside them through slowed time. Earth remained inside the wider clock of the universe. So while the travelers protected their own lifespan, they did so by letting the rest of reality race ahead without them. That is the hidden cost. Relativity saves the traveler from the full duration of the trip, but it does not save the traveler's world. In fact, it deepens the separation. It makes the one-way nature of the journey even more precise. Because now it is no longer merely that the traveler takes too long to return. It is that the traveler becomes untethered from the original era almost completely. This is why relativity does not solve the emotional problem of intergalactic travel. It sharpens it. A person can survive the crossing, yes. That part is extraordinary. But survive into what? Into a universe that has moved on without them. Into a home they can no longer share. Into a future so distant from their departure point that the word return becomes thinner than ever. This is sometimes called the twin paradox in simpler contexts. One twin stays home while the other travels at enormous speed and returns younger than the one who remained behind. It is a beautiful and unsettling thought experiment, because it takes time, which feels so universal and stable, and reveals that it is not shared equally by everyone under all conditions. But when you scale that idea up to galaxies, it becomes almost heartbreaking. Because now the twin who stayed home is not just older. The twin is gone. Their children are gone. Their civilization is gone. Their language has drifted or vanished. Their history may survive only as geology, archaeology, myth, or nothing at all. And this is what relativity does to the old dream of a heroic return. It does not forbid your body from coming back. It simply ensures that the place you return to is no longer the place you left in any meaningful human sense. That is why a galaxy will not wait. Not because it is impatient. Not because the stars resent you. But because the universe has no mechanism for keeping your world paused while you chase another one. Everything continues. Stars age. Planets change. Species evolve or disappear. Continents move. Cultures rise and fall. Even galaxies themselves are not frozen. They drift, interact, merge, and reshape over immense stretches of time. So even if relativity offers the traveler a kind of personal mercy, the cosmos as a whole remains indifferent. It keeps moving. And the farther you go, the more thoroughly that indifference remakes the meaning of home. This is what makes the idea so haunting. A near-light speed ship is not just a vehicle. It is a machine for becoming out of time with your own origin. You step aboard believing you are going on a long journey. What you are really doing is falling out of sync with the century that formed you. And perhaps with your entire species as you knew it. That is why the word one-way still holds. Even if the traveler physically turns around someday, even if the ship somehow survives both crossings, even if the people aboard remain alive through relativistic time savings, the continuity of the story is gone. The circle has not been closed. It has only been drawn in two different calendars that no longer match. If this quiet exploration of time and distance is helping you drift off, you can leave a like, subscribe to the channel, or simply stay here with the thought of it. And if you want to leave a comment, I'd love to know what feels stranger to you. The idea of traveling to another galaxy, or the idea that time itself would make you a stranger to home. Because that is the real emotional center of relativity. Not fast clocks. Not equations. Not diagrams. Strangeness. The strangeness of surviving into a future that did not survive with you. There is something almost mythic about that. It feels like an old story in modern form. The traveler who leaves for what seems like a manageable absence and returns to find generations gone, kingdoms fallen, landscapes changed. Human imagination has long been haunted by mismatched time. Legends and folklore are full of it. A person enters a mountain, a forest, a realm beyond ordinary life, and when they return, the world has leapt forward beyond recognition. Relativity is not a myth, of course. But emotionally, it strikes the same nerve. It tells us that the universe contains a real version of that ancient sadness. Not through magic. Through speed, through geometry, through the way space-time itself is built. And there is another important detail here that often gets blurred in casual conversations. Relativity does not mean you are somehow cheating the universe. It does not mean the distance disappears. The distance is still real. The energy required to approach light speed remains enormous. The engineering burden remains staggering. The dangers we discussed earlier do not go away simply because time behaves differently for the traveler. In some ways, the challenge becomes even more severe. To benefit significantly from time dilation, you must move at speeds extraordinarily close to light speed. Not vaguely fast. Not just faster than our current probes. Truly extreme speeds. Fractions of light speed so high that the energy demands rise into almost absurd territory. And as speed climbs, so do the dangers of impact, heat, radiation, and every form of failure tied to motion through even a thin medium of particles. So relativity is not an easy fix. It is a brutal bargain. You gain personal time only by paying a nearly unimaginable cost in energy, engineering, and separation from the era you left behind. That is not a happy loophole. It is a harsher form of exile. Because without relativity, the traveler is defeated by lifespan. The journey simply takes too long for one life. With relativity, the traveler may preserve their own lifespan, but only by letting the universe age past them. Either way, the bond to home is broken. That is the real lesson. There is no version of this trip in which both things remain intact, your life and your original world. You may sacrifice one to preserve the other, but not keep both. This is why another galaxy remains one way even in the most generous interpretation of advanced physics. The route is not closed merely because the traveler lives through it. Return is not only about breathing. Return is about continuity. About stepping back into a world that still belongs to your memory. Relativity cannot guarantee that. In fact, relativity almost guarantees the opposite. The faster you go, the more completely your private timeline peels away from the one that shaped you. And this becomes even more profound when you imagine not just a trip to another galaxy, but a round trip back to the Milky Way. Suppose the traveler reaches another galaxy in what feels like a few decades on board, spends some time there, then turns around and comes home, also at relativistic speed. To them, the whole mission might fit within a human life. But back in the Milky Way, millions more years have passed. Their return would not be a homecoming. It would be a landing in a future so deep that even the stars in the local sky might no longer align with memory in the same way. The constellations would shift over long enough timescales. Earth, if still inhabited, would be inhabited by beings unimaginably distant from the traveler's civilization. Human descendants, if they existed at all, might regard the crew less as returning heroes than as artifacts from a vanished age. Think about that for a moment. You leave as a member of one civilization. You return as a fossil that still breathes. That is what relativity makes possible. And perhaps that is why the idea is so emotionally powerful. It reveals that time is not merely something we move through together. Under extreme conditions, it becomes part of the distance itself. Another galaxy is not only far away in kilometers or light years. It is far away in shared history. The trip does not just separate places. It separates eras. And the faster you travel, the sharper that separation becomes from your own perspective. You do not feel every year the universe spends moving on without you. You wake at the other side of it. That is beautiful in a scientific sense, and devastating in a human one. Because if you think about what people really want from exploration, it is not only discovery. It is continuity of self within discovery. We want to go somewhere astonishing and still carry home with us in a living way. We want the new sky to enlarge the old life, not erase it. We want wonder without severance. But intergalactic relativity does not offer that. It offers wonder with severance. It allows you to survive the crossing while quietly taking away the world that made the crossing matter. This is also why even successful relativistic travel begins to resemble time travel more than ordinary exploration. You are not just moving far. You are launching yourself into futures that no one around you will share in the same way. Your path through space becomes a path through historical discontinuity. And once a journey begins to behave like time travel, return becomes a strange word. Return to where? Return to which century? Return to which version of your people? Return to which Earth? All the old language starts to wobble. Home, journey, visit, come back. These are sturdy words inside a human-scale world. Against galactic distances and relativistic time, they begin to sound like old tools applied to new terrain. They are not quite wrong, just no longer enough. That may be the deepest quiet truth in this whole part of the story. Physics does not merely make the journey difficult. It changes the language we need to describe what the journey even is. A traveler moving near the speed of light toward another galaxy is not simply taking a trip. They are stepping sideways out of their shared era. They are preserving their own years by giving up their place in everyone else's. And maybe that is the most one-way thing of all. Not the direction of the ship, but the direction of belonging. Because belonging is made of shared time as much as shared place. You belong to a home not only because you know its roads and skies, but because your life unfolds alongside it. You change together. You age together. You remember the same storms, elections, songs, griefs, inventions, and ordinary mornings. Home is a synchronization. Relativity breaks that synchronization. Beautifully. Perfectly. Without apology. So when we ask why visiting another galaxy is a one-way journey, relativity gives one of the clearest answers. Even if the ship is fast enough, even if the crew survives, even if the body endures, time itself makes sure the old life cannot come with you. The galaxy ahead may receive you, but the life behind you cannot wait. And that is why the journey remains one way in the deepest sense. Not because motion stops, not because physics forbids the ship from turning around, but because the universe does not preserve your moment for later pickup. It keeps going. The stars keep burning. The worlds keep changing. History keeps unfolding. And by the time you have crossed the dark and thought about coming home, home has already gone somewhere you can never fully follow. That is the real sorrow hidden inside the hope of relativity. It lets you keep your years, but not your time. Part 10: The Strange Truth About Human Reach. By now, the dream has changed shape. At the beginning, it may have sounded simple enough. Not easy, of course, but simple. Leave the Milky Way. Cross the dark. Enter another galaxy. See what no one has ever seen. Maybe, if fortune somehow holds, return with a story large enough to make history feel small. But the farther we have followed that dream, the more honest it has become. Distance stripped away the illusion of nearness. Our own galaxy turned out to be far harder to cross than instinct ever suggests. Our fastest spacecraft, impressive as they are, shrank against cosmic scale. Human lifespan proved too short to carry the journey in the old human way. The empty dark between galaxies was not a road at all, but a wilderness of almost total absence. Radiation, impact, isolation, failure, and time itself turned the mission into something heavier than exploration. Return became less a destination than a word trying to comfort a reality too large for comfort. And relativity, which seemed for a moment like a secret mercy, revealed itself as another kind of severing. It may spare the traveler from some of the time, but it does not spare home from moving on. And so we arrive at the final truth, which is not really about another galaxy at all. It is about us. Because if visiting another galaxy is a one-way journey, then the deeper question is not only why. The deeper question is what that fact means for a species like ours. What does it mean to live in a universe full of places we can see, measure, imagine, even understand to some degree, and yet never truly reach in the way our hearts first want to reach them? What does it mean that the night sky offers both invitation and refusal at the same time? That, perhaps, is the strangest truth of all. The universe is open to our minds in ways it is not open to our bodies. That is a hard thing to accept at first. Human beings are builders, movers, boundary crossers. We crossed deserts and oceans. We climbed mountains and sailed beyond horizons. We flew. We orbited Earth. We stepped onto the moon. We sent machines to the edge of the solar system and telescopes deep into the ancient light of the cosmos. Our story, in many ways, is a story of refusing to stay still. So it feels natural to assume that every visible frontier will eventually yield to motion. That every light in the sky is only waiting for its century. That the history of exploration will continue in one smooth line, from caravels to spacecraft to starships to galaxies. But perhaps the universe was never obliged to preserve that pattern forever. Perhaps some frontiers are not there to be crossed in the old way. Perhaps some exist not as roads, but as mirrors. Mirrors that show us what kind of creatures we are, and what kind of reality we live inside. Another galaxy may be one of those mirrors. Because when we stare at it long enough, we do not only learn about distance. We learn about scale, patience, vulnerability, and the true size of home. We learn that being able to see something does not guarantee the right to stand beside it. We learn that knowledge can travel where bodies cannot. We learn that understanding is not a lesser form of contact. Sometimes it is the deepest form available to us. That may sound like surrender, but it is not. Not really. Surrender is what happens when meaning disappears. This is something else. This is the moment when meaning changes. For a long time, humans tended to imagine knowledge and conquest as nearly the same thing. To know a mountain was to climb it. To know an ocean was to cross it. To know a land was to map it, name it, settle it, take hold of it physically. And in the smaller scales of Earth, that pattern often held. Bodies and knowledge could travel together. But galaxies do not necessarily allow that. A galaxy can be known from afar in ways that are astonishingly rich. Its distance can be measured. Its stars can be counted approximately. Its motion can be tracked. Its chemical composition can be studied from its light. Its history can be inferred. Its future can be modeled. We can learn whether it is approaching us, how massive it is, how fast it spins, what kind of structure it has, even how its ancient light connects to the broader history of the universe. That is a remarkable fact. A species that evolved on one small world under one ordinary star can look across millions of light years and learn real things about a distant galaxy without ever touching it. That is not failure. That is triumph of a different kind. And maybe that is the strange truth about human reach. Our reach is not only physical, it is intellectual, perceptual, mathematical, imaginative. We reach with instruments, with thought, with patience, with the ability to build ideas that extend far beyond the body that first had them. When we say another galaxy is out of reach, that is true in one sense and false in another. It is out of reach for our feet, our hands, our short-lived bodies. But it is not entirely out of reach for our minds. And minds matter. Perhaps more than we sometimes admit. Because the urge to physically go everywhere can hide a quieter question. What is it we really want from the distant universe? Do we want possession? Do we want proof that no scale can deny us? Do we want the emotional satisfaction of closing every gap that appears in front of us? Or do we want contact, wonder, meaning, perspective, and a clearer sense of our place? Those are not always the same desire. Sometimes they overlap. Sometimes they do not. Another galaxy may be one of the places where they come apart. We may never stroll beneath its stars and then casually return to Earth in any way that preserves the old human shape of a journey. That may simply be too much to ask of time, energy, biology, and the structure of the cosmos. But we are already in contact with it, in the most literal way light allows. Its photons cross the dark and arrive here. Its gravity participates in the great motion of galaxies. Its existence changes our understanding of what the universe is. We are not sealed away from it entirely. We are joined to it by knowledge, observation, and the strange fact that seeing itself is a kind of bridge. That bridge may not satisfy the conquest instinct, but perhaps it satisfies something older and wiser. The part of us that simply wants to know. The part of us that can sit beneath a night sky and feel, at the same time, both small and connected. That feeling matters more than it first appears. Because one of the dangers of talking about impossible journeys is that impossibility can sound bleak. It can sound as though the cosmos is mocking us, holding beauty just beyond reach for no reason at all. But that is not the only way to understand it. Limits do not only diminish us. Sometimes they define what is precious. If the Milky Way is not merely a launch pad but our lasting home, then home becomes more valuable, not less. If Earth is not a temporary waiting room before we graduate to the galaxies, then Earth becomes what it has perhaps always been, a rare world, a deep inheritance, a place whose meaning grows rather than shrinks when measured against the surrounding dark. This is one of the quiet gifts of cosmic honesty. When we stop pretending that all wonders must one day become destinations, we begin to cherish the wonder that already holds us. Our planet is not ordinary because it is familiar. It is extraordinary because it is familiar. There is air here, water here, memory here, language, music, grief, laughter, seasons, children waking, cities humming, storms rolling over the sea, insects in summer grass, cold mornings, warm hands, libraries, kitchens, trees, silence. all of it happening on one small world inside one galaxy we did not build and cannot replace. Against the scale of the universe, that is not trivial. It is miraculous. And perhaps that is why the one-way truth of intergalactic travel feels so emotionally important. It pushes us, gently but firmly, back toward the reality we already inhabit. It says, do not rush so eagerly toward distant lights that you forget the rarity of the light you already live inside. A galaxy beyond the Milky Way may remain forever a place of study rather than settlement for beings like us. But that does not make our existence smaller. In a way, it makes it sharper, more defined, more rooted. It reminds us that being finite is not the same thing as being meaningless. In fact, finiteness may be what gives meaning its shape. A human life matters because it does not stretch across millions of years. A home matters because it cannot be replaced endlessly. A goodbye matters because time moves only one way. These are not weaknesses in the design. They are part of what gives tenderness to the whole thing. The universe may be vast enough to dwarf us, but that does not mean it erases us. It simply asks us to understand scale without losing heart. And that balance is where real maturity begins, both scientific and human. Scientific maturity is the ability to look at a hard truth without decoration. To say, calmly, that another galaxy is not a practical round-trip destination for beings like us under the laws we understand. To follow the numbers where they lead. To admit when physics is not impressed by desire. Human maturity is the ability to receive that truth without turning bitter. To keep wonder alive even when possession is impossible. To let beauty remain beautiful even when it cannot be conquered. Maybe that is the final lesson here. Not that the universe is cruel. Not that exploration was a childish fantasy. But that wonder does not depend on ownership. You can love a thing you will never touch. You can be changed by a place you will never stand. You can learn from a galaxy you will never visit. That may be one of the most adult things the cosmos teaches us. There is another dimension to this too, one that says something profound about civilization itself. Because even if no individual human, or no near-future human civilization, can make a meaningful round trip to another galaxy, the desire to understand still shapes what we build here and now. Telescopes become better. Physics becomes deeper. Mathematics grows more subtle. Engineering becomes more precise. The longing to know what lies beyond our reach still produces knowledge, tools, and ways of thinking that enrich life close to home. In that sense, the unreachable still bears fruit. It calls forth effort. It sharpens attention. It enlarges thought. So perhaps the true value of another galaxy is not that one day we will step into it like tourists in some impossible future airport terminal. Perhaps its value is that it calls us into seriousness. It asks us to become the kind of beings who can face immensity without lies. Who can admit that some distances cannot be crossed without giving up more than a journey should cost. Who can still look upward afterward and feel not despair, but gratitude. Because there is gratitude hidden in this realization. Gratitude that we are here at all. Gratitude that we can ask the question. Gratitude that the same universe which places galaxies beyond our ordinary reach also gives us minds capable of understanding why. That is a very strange arrangement when you think about it. We are small enough to be humbled, yet aware enough to know what is humbling us. We are brief enough to be fragile, yet intelligent enough to measure deep time. We cannot physically roam the cosmos as freely as fantasy would like, and yet we can hold pieces of the cosmos inside thought. That combination is rare, perhaps unimaginably rare, and beautiful. If this gentle walk through the edges of human reach has been a good companion for your night, you can leave a like, subscribe to the channel, or share a quiet thought in the comments. I always enjoy hearing what part of the universe lingers in your mind when the day finally goes still. Because maybe that is the real way the cosmos enters our lives. Not through conquest, not through ownership, but through lingering. Through the way certain ideas stay with us after the lights are off. The way a galaxy millions of light years away can somehow make your room feel quieter, your breath feel slower, your own life feel both smaller and more precious at once. And in the end, that may be enough. More than enough, perhaps. Another galaxy is a one-way journey, not just because the engines are too weak, the distance is too large, the dangers too deep, or time too strange. It is one way because the universe itself is teaching us that some roads cannot be folded back into the old human shape of leaving and returning unchanged. Some journeys, if taken at all, become transformations rather than trips. Some distances do not allow the traveler to stay the same. Some destinations cost the world that made the destination meaningful. And when that becomes true, wisdom begins to look less like reaching farther at any price, and more like seeing clearly what is already within reach. A sky overhead. A planet beneath you. A galaxy holding your star among billions. A brief life able to ask impossible questions. That is not a small inheritance. That is enormous. So perhaps the final image is not a ship vanishing toward Andromeda, though that image has its own lonely beauty. Perhaps the final image is simpler. A person standing under the night sky, looking up at a distant galaxy and understanding, maybe for the first time, that it is both real and unreachable in the old sense. Understanding that the light crossing the dark is enough to connect them, even if the body never will. Understanding that there is dignity in limits, and wonder in clarity, and peace in letting some stars remain far away. The galaxy does not come closer. The person does not become larger. But something important settles anyway. A kind of calm. A kind of truth. And maybe that is what the universe was offering all along. Not a ticket outward, but perspective. A reminder that we are small, yes, but not meaningless. Finite, yes, but not empty. Bound to one corner of the cosmos, yes, but capable of understanding corners far beyond our reach. That is the strange truth about human reach. We do not have to go everywhere to be touched by the universe. Sometimes it is enough to look, to learn, and to let the distance teach us what home really is. And under a quiet sky, that truth can feel less like a limit and more like a blessing.